Hi, Rajib. Hi, Manny.
Hey,
Hi,
hi.
Sachin. Nice to see you guys.
Hey,
So we've
hi.
got
Hello.
two people that have got the same VMs. What are
Oh,
your
damn.
guys' emails? Wait, did you get from Dylan or Landre? Dylan and Dylan at Alta and Kyle SH got the same VM, and their computers are controlling each other.
Okay, can you please type their email IDs in the chat? I'll have a check.
Okay. Where's my phone? We'll do it now. I'll just grab it. Yeah, sorry, before you do that. Sorry, before you, can I grab the phone? Give me the phone. Oh shit, they're putting it into some Ghana chat. Okay, that's fine. Wrong one. Um, can you just put your emails into that quickly, into that chat? Um, so yeah, Manny, Sachin, Rajdeep, we're just also creating a list of people that do have, so we can say those can stay, and then maybe you can forward to people that don't have, and we'll try to do that.
Cool.
Yes. It's not working. Elantre at okay, we'll sort that out. Do you want to just put your email address into there? Go send. Send, yeah. So those two that have just come through on the chat are the ones that the VM is sharing between their two computers, Dylan and Kyle. Yes. Just no, just the one that is a problem. Okay, so the one that's not accessible. Just okay, cool. Thanks. And the Elandra one that just came through to you guys is not working. The VM is not working. So I don't know if there's a way of refreshing it on your side or trying to rejig it. Right,
Oh, by the
right.
way, I haven't got any IDs in the chat.
They're on WhatsApp, I think, Sachin.
Oh, okay, on
Yeah.
WhatsApp. Got
Yes,
it.
yeah. Elandre at Alta VR, their VM link is not working. Yeah, do you want to add your people who have? Please add. Morning. How's it going? Cool. Anyone out there in the world that's doing stuff? If you've got issues or you're not getting VMs and you're watching this from home, you can also WhatsApp me on 074 788 147. I'll give it again. 074 788 147. Where did my phone end up? Oh, there we go. Who else has got one working? You guys have, eh? Okay. Put your email address into there, please. If you've got one working, please put it into there. It'll come through. Not yet. I'm just trying to trying to work out who's got and and there's a whole lot of other emails floating around that aren't here that also have, but they aren't here. So we're just trying to sort that out. So the ones coming through, is it all on one message? No, it's So the ones coming through to you guys are the ones that have at the moment. And we'll try. Anyone else? You have one. Okay. Can you pass the phone back to him? Yeah. Yeah, but
we don't know who they.
process of elimination, unfortunately. You're up there.
Yeah.
Okay. And put your email into there as well, then, so we know that they've got you. Sweet. Cool. So Manny, I've just sent you a list of the people that are set up. Those guys are set up, and then it's so I don't know if you are able to forward some VMs to some other people as well. Can I give you guys a list? Are you able to forward a whole lot of VMs still?
So just to clarify, the emails you've sent me just now, those are the ones which are working, right?
Correct.
Okay, perfect. Got it. So we've requested 2 additional machines currently. Will you need any more?
Say again, sorry?
We've requested 2 additional machines for the 2 email IDs you sent across.
How many people need more? Put hands. You're meant to be, okay. You guys are meant to be linked. Sorry. It's all meant to be linked. There's apparently, somehow, that's what they've said. 1, 2, carry hands up, keep 1, 2, 3, 4, 5. You've got, yeah, 1, 2, 3, 4, 5. Okay, I'm going to get you these guys to send their emails to you now, and if you can pass things through to them. Okay, so
Understood.
it's coming to you, Manny.
Okay, got it. No problem.
Cool. Just pass it along. We'll get there. They've got. Who hasn't got You don't have, but you're not going to log in. And then you guys, yours as well. Just put it in there. Yeah, cool. Okay, yeah, Manny, it's those 5 from CJ at Open Window through down to Chris Sachs at Gmail.
Okay, superb. On it.
Thank you. Let me see what they say. You guys just stand up there and wave. Stand up, wave. Yeah, stand up. Yeah. Perfect. Not you. You're not them. Yeah, you can show them what it's doing on your screen. Okay. You can see what they're doing. That's those 2 dudes at the back. Maybe it has to be one separate one sent to one of them. Okay. So you might have to share one machine, otherwise they're going to try provision one for you. I think we're going to go to the lead now. Okay. People who didn't have you got anything yet? Chris, have you got anything yet? Okay. So they've got emails saying a link is on its way, but it hasn't come through yet.
Yeah, I think that should take another 15 to 20 minutes. I've already let the team know about it.
Okay. So guys, I think we'll have to start cracking off, and just keep an eye on your emails. They'll come through to you guys as well. So just keep an eye. Okay. All right, Shruti, do you want to do a little intro? Okay, thank you for joining, everybody. Going to invite Shruti to come and say hi to you, and then we'll hand over to the training team to show you and start the program.
Thank you, Rex.
Speak right into the mic before we hear you in the rest of the world.
All right. Hi, everybody. Good morning. Oh, I need a better good morning. Come on. An energetic good morning. You have 2 hours of staring into the system. So thank you everyone for joining our first boot camp on learning Unreal in South Africa, and this is our first foray into the market, and we hope to bring you more training sessions along with Rex and his team. But just to introduce ourselves, I'm Shruti. I head business for Unreal Engine for India and Middle East Africa. I have my colleague Saishri sitting right behind. She heads BD for games for the region as well. And then yes, we have Rajdeep, Mani, Sachin, all of them joining remotely. Unfortunately, Rajdeep could not make it in person here due to visa delays, but thanks Rajdeep for joining us online and taking this session. So they are from Rajdeep and the team are from Green Rain, who are our Unreal training partners, and they've been training about more than 8,000 people in the last 2 years on Unreal Engine across the world actually right now. So largely India, Southeast Asia, but now we add Africa as well into our training contingent. So what to expect? I think Mani and Rajdeep will give you a house cleaning tip on how to manage your VMs, but this is how, as Unreal, we are trying to break away the barriers of entry and learning Unreal is by providing virtual machines and learning tools for all of you to learn Unreal easily and not just limited to your systems, but how can you learn and apply Unreal across various verticals and across various applications. Just a quick sense check. How many of you come from a video games industry? Okay. How many animators here? Awesome. And visualizers, architects? Cool. So yeah, I mean, this is just the first boot camp, which is about making your first game in Unreal in 2 hours. But there are various other courses and curriculums that you can learn, and you can, sign up for training with us for those if you want to learn animation, you want to learn virtual production, or architecture, or use Unreal for automotive industry as well. So there are quite a few training programs that we provide, and we'll love to stay in touch with you and help you get your growth started with Unreal. So without further ado, Rajdeep, do you want to take over?
Absolutely. Thank you, Shruti, for that wonderful introduction. I guess I'm audibly reachable by everyone. Can you hear me? All good from my end?
Can you increase your volume, Rajdeep, a little bit?
Sure. Give me 1 second. Give me 1 second. I guess Zoom is also playing a part in this. Let me see. What about now?
Yeah.
Is the volume good?
Yeah, little better, yes.
All right. I guess says Sachin is saying it's a little bit of crackling at his end. Is my audio crackling at your end?
A little bit. I think it's a
Okay.
Zoom.
Not
I
here.
guess
It's clear here, right?
it's not there. Only it's at Sachin and Manan's end.
So it's probably not happening there because they're on the speakers and we're on headphones. So
Probably.
it's not
Probably.
audible, most likely.
All right, cool. So good to virtually meet everyone. Unfortunately, I couldn't be present there as Shruti mentioned. So you know what? When life gives you lemon, you make lemonade in India. So I'm here in India making lemonade with my situation. Anyways, lovely to see all of you in this workshop. I'm seeing that you guys are already set up with your VMs and everything. I have eyes behind you, by the way, so if you do mess up, I can see that. Anyways, don't worry about that. My name is Rajdeep, as you all know. I'm an Unreal authorized instructor with Green Rain, and I'll be your trainer for today. And let's have some fun, all right? So, Shruti, I just wanted to ask, is it 2 hours or 3 hours for the session today?
2
Just
hours.
to be sure.
2 hours.
2 hours, all right, cool. Got a tight window
Greg
to
says if
complete
you
a
ca-
game.
It's okay. Go ahead. Go ahead.
All right, cool. So as I was saying, quite a tight window for a fully fleshed out game. However, we'll try our best to get there. And I need your cooperation, and by which I mean you speak out whenever you have any issues. Please interrupt me or raise your hand. I think, I'm not sure if everybody has mics, but I guess a mic can be passed on to you if you have questions. Just ask whenever you can so that I can help you with whatever issue you have so we can move ahead, all right? And the whole idea is to make this fun, all right? So we will be making a small, I would say mini bowling ball game in Unreal. But before we get started, I want to take a little bit of poll from you guys. Everyone who have used Unreal Engine before, could you please raise your hand? All right, so I would say quarter of you guys. I'm not sure if there are more people behind the camera. So I would say some of you. So among the people who have used, or the ones who have raised your hands, who have had completed making a game of your own, or rendered cinematics or any kind of interactive use cases that you've used Unreal for. So one, I can see one. Is there more? Two. Nice. All right,
Yeah,
cool.
two.
So yeah, I see your hand. I see your hand. All right, so the idea is to be able to make this game easy, as in make this session easy enough so that anyone who even if you have not used Unreal even the day before today, you'll be able to follow along with me. So for somebody who has been using Unreal for some time, this will be a little basic for you, but the idea is to be able to keep up with everybody, all right? So yes, a mini game within 2 hours. Let's get started. I'm gonna share my screen and we'll take it from there. I have a little bit of a presentation which is about a basic overview of how games are built in Unreal, as in the foundational structure that everybody needs to understand in a game engine. I believe that some of you are from ArcViz. You've had 3D experiences, so you do understand the 3D side of things. But when it comes to interactive game development, there are certain things that you should understand if you have not used Unreal before. So we'll just go through a little bit of a presentation and then we will jump right into Unreal, all right? So give me 1 second. I think the host has to give me screen sharing ability. I think it's disabled for me. Okay, it's good for me now. Just let me know when you guys can see my screen, all right? All good? Okay, let's get started. I have a little bit of a presentation, as I mentioned. We'll go through that. We'll talk about what it contains, why it's necessary to understand this, and then we will jump into Unreal, all right? So this presentation is mainly going to cover what is called gameplay framework, okay? And gameplay framework just is a overview of what is already in the engine, which is going to hold your hand with you trying to make any kind of interactive experience. It doesn't have to be a game, all right? Any kind of interactive experience. Today, obviously, we're trying to make a mini game, so in that case, it becomes very important that you understand a little bit, at least if not entirely, what gameplay framework contains. All right, so what is it, why is it important, why do you need it, is what this presentation is going to contain. All right, so when we talk about gameplay framework, or when you think about being able to create a game, doesn't matter what kind of game you're trying to create, you'll see that when you draw like a Venn diagram of all the genres of games or the types of games that you have, there is a certain overlap, and in that overlap region you'll see that almost any kind of game will require a few fundamental things which are almost always repeated, and almost every game developer will need them. So what the engine has done for you is created those, I would say, foundational structures already, which is present in the engine, and you can just pick up from there, understand how that works for your game, and then continue forward to create something that is custom to you, right? So that is what the gameplay framework is. It's a set of foundational classes, which is at the absolute basic requirement for the functionality of any kind of game, right? And basically you'll just be deriving from this source and then customizing it as you need. And it does not really matter what kind of game, you will always need help from the gameplay framework, and you have to build it as for your own requirement. All right, so as I said, it's required because there's a foundation structure which years of game development has brought on, that anyone with any kind of game development background will realize that that is always needed. So, and the more you use it, the more you'll understand that this just organizes the game better. And a lot of complications that a solo game developer, or even a team for that matter, they face, this is already solved for you. So you don't have to reinvent the wheel. You just have to accept the help that the engine is providing you, right? So, and again, this is built with foresight. So some of the issues you might be facing now, but some you'll realize later. So that's already taken care of. So if you follow this formula of sorts, you'll basically be sorted for any problems to come. And this is again just a brief showcase of what a very simplified showcase of what happens when a game starts. You have the engine, which starts what is known as a game instance, within which your level that you're trying to load is brought in, and then something called as a game mode is started, and within which what is the player, what is the UI, who controls the player, etc. They're all brought into the scene. So that's the sequence of things that happens when a game starts. All right, this is not something that you have to catch on right away. You just have to understand that this is how things happen. Doesn't matter any kind of what kind of interactivity you're trying to create in the engine. All right, and there are some things that are essential to any kind of interaction that you want to create in a game. There are some jargons that you might hear in the future. Even with us trying to do this session right now, you'll be hearing these words. So it's all in the screen. We don't have to totally understand what these mean, but you will be hearing these words like classes, objects, actors, pawn, character, controller. So these are all a developer, these are all words of things that you have to pick up on as a developer if you have to be able to create games on your own. Like classes are basic programmed structure of data and code, and like for example you need a animal in your game, so that's a, you'd say, animal class, and then from that animal class you derive and you create either a rabbit or a horse. It's up to you, but the base structure of that animal is already created. Just an example. All right, object is the master class. You don't have to understand that right now. Actors are anything that exist in your world. Like, you know what, an alternative word for that would be stuffs in your level, like a chair, table, maybe a road or a car. These are all actors that exist in your level, right? A pawn, maybe the car is a pawn. Why? Because you can possess it, like in GTA, where you shift from being Michael and you enter the car, and the car becomes a pawn. So you play the game as the character, and that can be a pawn as well, or the character class, and the car then becomes the pawn when you possess it. So pawns are basically any actors that you can possess, and there will be something that we'll be creating something like this in the session today. And character is basically a pawn with fleshed out body, like a humanoid or any kind of animal. And pawn basically can be anything that you can possess. Character would be essentially something with a physical body that you can look at and animate and stuff like that, right? And controller is basically the mediator that takes input from you, the player, and passes it on to the pawn, so that, say for example, when you press W, that data is then taken by the controller and it's then converted into information for the pawn, as in move forward with this animation, etc. All right. So this is all that is working under the hood when we are trying to play a game. Okay. We'll put this all into practice now. Again, I've kept this simple. We don't really have to understand gameplay framework and its complexity, because it can get really complex. We just have to understand what's happening, at least on a surface level. That's the whole idea. Now I'm going to share, we don't need this presentation anymore as of now. I'm just going to share a link with you guys in the chat. It's a Google Drive link that you guys will need to download from, and I want you to open the browser inside the VM to access this link, not the browser of the computer that you are sitting in, the browser inside the VM. Use that. If you can't see a browser icon anywhere, use the start button, look for a browser like Edge, Chrome, Mozilla, whatever, and use the link over there. I'm just going to paste it in the chat. Give me 1 second. Again, it's a Google Drive link which will give you access to, just give me 1 sec, this particular file. All right, it's literally called files.zip, and it's small. I don't think it's really large. It's about 38 MB, so it should be easy to download. Okay, and once you get it, you just unzip it. It'll contain some files that show you what you should be expecting from within that zip file. There's the presentation which
Rajdeep,
I showed you.
no, I think he's pasted it up on the Zoom link. Show the. No, so Rajdeep, can you come again on how can everyone access the link on their VMs?
Sure. So just copy the link.
Not everyone is
Within.
No. No one can access that Zoom chat link because it's just at the backstage. You're just logged in into a Zoom link from here. Everyone is not logged on to Zoom. So.
Oh, okay.
Yeah.
Oh, yeah, because they're just watching the screen over
Yes.
there, right? Is there a way we can share the link with everybody?
Yeah, if you could just email the link to everyone.
Sachin, could you be able to share
Yeah.
the link with everybody?
Yep.
So guys, just give it a minute. You'll get the link in your emails. Just don't open the link in the computer that you're on. You have to open the link inside the VM within the computer. Okay, so as in within the VM you should have a browser, just like you're about to open Unreal within the VM. Just open a browser within the VM and use the link over there. you know what, while you're receiving the email and while that's happening, unless you've already received it, let's do something to make up for, you know, the time we have till we receive till everybody receives the emails. We'll just open up Unreal at our end, set up the project and wait for the files. All right. So, and by the way, it's not 100% necessary that you do get the files to be able to do this. It's just that we are using certain specific assets, like, you know, we're making a mini game. It's a it's a bowling ball game, right? So you already realize that we have a very specific set of assets which we will need, like the pin and the bowling ball, right? So I mean, you could replace the bowling ball with any sphere and the pin with a, you know, shape, but then it won't be the same. So the files are there for that. So if you get access to it, really good. If you don't, you're not really losing out on much. What we'll do is we'll just set up the engine and the project and then wait for the files. Okay. Cool. All right. So while all of this is happening, just start up Unreal. I hope you have 5.1. It's not going to make a difference if you just have 5.0.3 at your end or any other version within 5. It really doesn't matter. We're not using any absolutely new features. So I'm opening 5.1 at my end. You can use the launcher to do the same, or you could look for the desktop icon if it exists, or you could always go to the start menu, type Unreal and get the engine from there. From the launcher, you would be able to access the engine from the library, and therein you'll be able to see which all versions of the engine is installed, and you can launch it from there, or just look for the desktop icon and you can launch the engine from there. All right. So in my case, it's over here. It's 5.1. I always rename the desktop shortcuts with the version name of the engine that I'm using. I'm gonna start it off from there.
Rajdeep, I just pasted a link in the chat.
Yeah.
Can you please show it
Yeah.
up on the screen? You can just type it in and they'll have the link.
All right. So here's a
I think-
link. I don't think Zoom UI is visible in screen share. Or what I'll do is I'll copy this and
Yeah, I'll
paste
look.
it in Notepad and show it to everybody. All right, can everybody see this link? Just type bit.ly/Unreal Engine Training. Again, bit.ly/Unreal Engine Training. And whoever is there present, I just need your help to check if they're opening this link within the VM and not using the computer's browser to open it. Guys, you have to use the VM's browser so that the files are downloaded in the VM, not your computer. Okay? Again, bit.ly/Unreal Engine Training. If you guys are able to access it, could you give me a thumbs up? I can't see you guys. You're pretty small in the screen share. All right, cool. So again, once you access that link, you're gonna get a zip file called files.zip. Just keep it anywhere, and you're supposed to unzip it, and you'll find these stuff inside. You'll find the image, you'll find two FBX files. They are They're just two 3D models, all right? You have the presentation in there, and you have a texture. So the really essential files are the last three. They're called SM bowling ball, SM pin, and bowling ball diffuse texture, all right? So this is what you'll need. If you don't extract the first two, it's fine. You'll need the model and the texture, all right? So extract it somewhere and keep it, and when you need access to it, I'll let you know. You don't need it right away. You'll need it later, all right? I'll let you know. So let's begin. I have Unreal Engine 5 open in front of me, and when you want to begin with any project, obviously you have to ask the question, will I be gaining a lot from choosing a very specific category and template from here? If not, you can always start lightweight, and that's exactly what we're going to do, all right? We are not looking to take advantage of any particular template from here, but feel free to do that in your case, all right? Because obviously these templates are really extensive. They have stuff which are pre-made for you that can help you, get ahead. All right. So for today, we're going to be in the games category using the blank template. All right. Not anything else specifically. Games and blank. And for the project settings on the right-hand side, we're not looking to change them at all. As you can see, we're choosing to use Blueprint and not C++. It means that we are trying to visually code our interactivity within the engine. If this was any other case wherein we wanted to code it in C++, then we would have chosen C++, but we are not doing that. We're using Blueprint, right? And the last thing we need to do is choose the directory where the project will be stored and the name of the project, all right? And we can do that from the section below, okay? So choose a particular directory. Mine is already chosen, and I'm going to give it a name. We'll call it bowling ball mini game, so MG for that, right?
So I just have a question. If the choice between blueprints and C++, if that decision matters at the start, or can it be changed halfway through the project?
Oh, it can be changed anytime throughout the project pipeline.
Thank you.
So say, for example, you started off as a Blueprint project and later realized that you're hiring someone or you're partnering up with someone who is a C++ developer. Then midway through, you can convert the project as is. It won't really change anything. As a sole Blueprint project to a Blueprint and C++ project, wherein you can continue doing your Blueprint stuff, that it won't really make any change for you, but at the same time the C++ developer can also pitch in and code for your game. And it's the same if you go for the C++ option. The difference is, if you choose C++, it already sets up the project as a C++ enabled project, as in you can code from the very beginning, instead of just being Blueprint only. All right, that's the only difference. Cool?
Yeah,
All right.
I see a couple of editors still booting up.
Oh,
How
cool.
many? Yeah,
Okay.
1, 2. Has everyone opened the editor? Because are you able to access the first screen? I know you're still booting your editor, right? Oh, okay. Okay. Cool. Can we go to the next step? Everyone, are you okay? Can Rajdeep go ahead? Go ahead, Rajdeep.
All right, cool. So all we have to do at this point is just press create, which is where you guys are, or will be once you choose your template. So the moment the engine's loaded, you have this pre-made level already present in front of you. You don't have to worry, you don't have to work here. This is just something that the engine creates because it can't exist without a level present in front of you. It's not saved or anything, all right? Will not be working here. We'll make use of something else which is already present, all right? So I'll just wait till everybody is at least at this stage where the UI is open in front of you.
Rajdeep, 2 students need help here.
Well, it's more the computers themselves.
Oh, okay.
Oh wait, it's saying like the graphics drivers are updated basically.
So on the VM or on the machine?
Just on the VMs, okay, it goes through.
Just click OK.
Okay. Just wanted to make sure we were
Is it okay now? Yeah, go ahead. All right. Yeah, go ahead, Rajdeep.
All right, cool. So if your editor has opened up, this is what you're going to see. If it's any different, it doesn't really matter. Also, your UI and your panels, if they're not looking like how my UI and panels are looking like, then you can always go to Window on top, the menu window, and then come all the way down and look for Load Layout, and you can choose UE4 Classic Layout. I always suggest anybody who is learning Unreal for the first time, because I've seen a couple of people who said they've not used Unreal before. So if that's the case for you and you're learning Unreal for the first time, you should be using this particular layout, because that always keeps the necessary panels which may be hidden right in front of you, so that you don't have to go looking for them. You don't have to go being lost looking for certain hidden options in hidden menus. All right, so it's essential that you do this when you're learning. Later on, when you take the training wheels off, you can always go and choose the default editor layout, which is default for Unreal Engine 5, which is a minimalist look wherein you have maximum space given to the viewport and the panels are all hidden, and you use shortcuts or hotkeys to bring them up. Okay, so I'm going to use the UE4 Classic layout for today. Okay, and I hope you guys do the same, because then everything will be right in front of you and you'll not be lost. All right, so the first thing that I want to do, besides changing the size of the folders in my content browser, just a brief explanation of what the UI is for everyone who has not used Unreal before. You have some stuff that is already present in the engine that you get from this panel. You don't have to understand much right now. There are others who have used, so I have to keep up with them as well. So, and there's a browser below where you can create files which are not already present for you. So there, again, just to repeat myself, there's some stuff which is already there for you, pre-created, just like any other software. Like, you're using, let's say, Photoshop, and you need a shape, like a basic shape. It's already present, right? And a content browser below where you can import stuff or you create some files within the engine. On the right hand side, you have the outliner, which shows you the list of items which is present in this particular level. All right, so all of these items on this in this panel right now is the list of items which are present in the level that you're working on. And the details panel, just whenever you click something, it shows you the details of that item. It's as simple as that. For now, for anyone who is using the engine for the first time right now, this is all that you have to understand. Otherwise, just follow along with me, okay, step by step. When you get stuck, just raise your hand, let them know, and we'll follow up with you. Cool. All right, so we're not going to work in this level. Imagine having to be present in the middle of nowhere playing bowling right here in the middle of the landscape. So we're not going to do that, obviously. So we need a fresh level for ourselves. What we're going to do is go to the file menu on top and choose new level from there. Okay, alternatively, you can create a level on your own as a file from the content browser. If you right click in any empty space and choose level, you can do that. But the difference is, if you use file and new level, you get this window where you can choose one of the template levels, and I'm going to choose basic. Okay, basic is where your lighting is set and you have this one flat area where you can prototype stuff. All right, so basic is how we will begin. All right, again, repeating myself, file, new level, and then you get this window. You have to choose basic. Okay, select that and press create, and there you go. A simple flat plane where you have the atmosphere and lighting, all of that created, so you don't have to worry about that. Okay, So we can get started over here, and there are some icons in the center of this level. You can reduce or increase your camera speed if you feel like it's not slow or fast enough. For anybody who doesn't know navigation in Unreal, you just hold your right mouse button to move the viewport, and just like you're playing any other first-person game, you use your WASD key while holding down the right mouse button. All right, so you just select these icons. You can use control and then select, so you can multi-select and then push them out in the corner so they're not in the middle of the map. And to begin with any kind of prototype, you need to ask yourself, what is the absolute quintessential requirement for this experiment or this prototype that I'm trying to build? Okay, so our goal here is to make a single lane from a bowling ball arena, or whatever you want to call it. Okay, so what are the essential stuff? So we need one long lane. Like imagine you're in a bowling ball arena, right? So one long lane, and you're playing at the very end of it, this side, and on the other end there are some pins on the ground, 10 of them, and the idea is to launch the ball, which is going to go hit as many pins as possible to give you any score from within 0 to 10. If you strike out all of them, well, you win that round and you get to start again, or you score less and you get to start anyways. So the absolute basic stuff that you need are some models, right? A lane, the ball, the pin. That's the absolute quintessential stuff. So when you know these things, at least you have asked those questions, so you know what you need. Now you need a little more information than that to get things right. Like for example, what are the dimensions of a bowling ball lane? Like you can obviously get a basic shape from the place actors tab shape category. You know, you get a cube and you can stretch it out and you make a lane like this, but it's always going to be an approximation of what the real thing is. It's always a good idea to at least get your bases right, you know, get the dimensions right, and you can always Google. I've done the Googling for you. It's already present in the folder which I seem to have closed. Give me 1 second. Yeah, so there must be a JPEG which I've you know, put in the zip file. If you open that up, this is just a basic showcase of what a bowling ball lane looks like. So the length is basically 60 feet up till here, which is where you stand, and then beyond that there are, I think, 15 more feet, so give or take 75 feet long, and it's 42-inch wide. It's funny how one dimension is given in feet, another dimension is given in inches. I wish both were in inches. It's just convenient, maybe. All right, so what we need to do in Unreal whenever we're working with dimensions, we need to consider everything in centimeters, at least to start off with. You can change that basic rule inside the engine from centimeters to meters or inches. You can always change that unit, but by default Unreal works with Unreal Unit, and 1 Unreal Unit is equals to 1 centimeter. So we need to convert these values into centimeter to be able to make them useful for us, right? So let's do a conversion. It's not 60, it should be 70. So let's do a conversion from 70 feet to inches. I'm sure you guys are on Windows, so you can always go to the start menu and type calculator, and that calculator gives you an option to choose whether you want a standard calculation or you want to do length conversion. Okay, so I'm going to do that, and I'll change the conversion from feet to centimeters, and 70 feet is give or take 2134 centimeters. So that's our length. Okay, and we'll do a, and I need to note this down because I forget things very easily. I suggest you do the same as well, or while I'm doing it you can follow along with me, it doesn't matter. So you know what, let's round this off, 2130. Okay, as the length of the lane, and the width of the lane is a conversion from 42 inches to centimeters. So we'll change this from feet to inches. Let's try 42. That's about 106. Now I've tried this on my own before. 106 seems to be a little too narrow. I know these are real world values, but there are some liberties that you can take, by the way, and you can change. We'll change this from 106 centimeters to 130 centimeters. That gives us a little more width to place all our pins properly. That's all, right? So length 2130, width 130. These are all in centimeters, and we're going to use this to create stuff right inside the engine. We don't need to go elsewhere, measure stuff, model them. We can do modeling right inside the engine, by the way. And for that, what you need to do is, first of all, let's just save this level. So you go to File, Save Current Level As, and then you can choose any folder. You can create your own folder in here, call it Levels, and save the map within that, or you can just save it outside. We'll call it BB underscore game or map underscore 1, bowling ball map 1. Okay, you cannot use space or any special character, so the best alternative is underscore. All right, so you give it a name, you save it, and now you've created this file which is your access to this level. All right, anytime you get out of it or you're going to another level and coming back, all your work is saved. All right, so let's get to modeling, and for that we need to go into this mode selection on the left hand top corner of the UI, and it's right now on selection mode. You need to change this to modeling mode. Okay, and you may get this floating toolbar over here. You can dock it anywhere you want. I'll dock it right on the left hand side of the viewport. Okay, so it should look like this. You can dock it within the panel, but then you'll have to swap a lot of panels in order to use this tool properly. So it's a better idea if you just dock it right on the left hand side of the viewport like this. Okay, and then you can squeeze it to get more view space. Right, so just so you know, the UI structure of Unreal Engine is very malleable, as in if I didn't want this panel to be present in this screen, in case you had multiple screens, you literally take this and put it on a different screen, save this layout, and that's, if you wanted to work like that, you could. All right, so to begin with, we need a lane which is a certain length long and a certain width wide. All right, so some of the basics, one of the basic shapes here can help us with that. We can choose box. All right, and the moment you do that, you should be in the modeling panel as well, so that you can see the details of the tool that you've selected. Right, so I've chosen box, and now this details, they help me select the dimension of the box that I want to create. So width would be, I believe, 130, right? So 130. This is all in centimeter. It's not written, but it's in centimeters. All right, and the depth, which is basically in this case the length, would be, what was it again? 2130. Right, so 2130 would be the depth, and the height is basically how fat you need that to be, right? How thick the layer of that object you want. And now 100 seems a lot, so I'm gonna drop it to say about 10. And if you move your mouse around, you can see it gives you a preview of that lane that we're trying to create, and this looks fine to me. So the moment you're happy with this preview, you can just click anywhere in the level and it'll create a copy of that. All right, and then you have it in the level, as you can see. All right, so that's it. Like, you put the dimensions, you click once in the level when you're happy with the preview, and that's it. You press accept in this dialog box in the center of the screen, and it'll give you that asset. So you're ready with the lane, right? If you want to be precise, you can just go to the top view, and you can change that from this menu option over here. You can change it from perspective to top view and zoom out So you can center this in the map. It's up to you. Alright, if you want to have it in the corner, that's fine. So there you go. So it's all in the center right now. And we need to, let's say, for a bowling ball lane to work, and if you know this, you'll know that the lane has gutters on either side, right? I don't think that preview image has it. No, this doesn't do justification to that. You see, on this left hand side of the lane, on the right hand side of the lane, there are two gutters that run in order to catch the ball if you're not too straight with your throw. Okay, just so that if your ball is going off the lane, it's just caught and brought back into the feeder machine or whatever that is, right? So there are two lanes that run on either side, and I have to carve that lane out. It's basically like a negative cylinder sort of it's like a curve, all right? So we need to make that. And one of the things that you can do with the modeling assets or tool sets in Unreal is you can use a Boolean argument to carve out a shape from an existing shape. So what we're going to do is we're going to make a long cylinder, and we'll use that to carve out the shape of the gutter that we need, right? So you would be doing this anyways in a modeling application and then bringing in your asset. Nobody's stopping you from doing that. I'm showing you this because you can create anything custom that you need. If you're prototyping or not, if you want to create final assets or not, right within the engine. Okay, so I'm going to click on cylinder now. We were using box before, so I'm going to use cylinder now. And the radius can be the radius of the actual the half of the diameter of the actual ball. All right, say the bowling ball. All right, so we don't have that value right now, so I'm going to drop it to 10. And you can drop it even less, but 10 seems fine. And we need the height of this cylinder to be the length of this lane, all right, which is 2130 or even more. We can actually go round it off to 2200. So the radius should be 10, height 2200. Radial slices can increase, that is how well defined the cylinder is, say about 50. You can copy these values, 10, 2200, 50. All right, and now I'll just click once to create this and press accept. So you have a long cylinder, as you can see, and I'm just gonna rotate it on the side. You must be wondering, how did I get the rotation gizmo? The shortcut is E. Okay, so you select anything, you press E, you get the rotation gizmo. So you can rotate it on its side, and the idea is to place this cylinder right at the corner, left hand side corner of this lane, so that I can carve out the exact shape that I'm trying to get in the lane from this cylinder. All right, I can always go to the top view to do this properly. Okay, so you need this cylinder to be inside the lane, not outside. This is the lane that we have created. Inside the lane, you can change your snap, location snap from 10 to 5 if you want to be a little more precise. And there you go, right? I'm also gonna make a copy later for the other side, but we actually don't need it. So once you have the cylinder placed on the side, you need to select both of these assets, and you're looking for this option within the modeling tool bar called, it's a little below the initial tools, it's under poly model category. It's called MSH bool. It stands for mesh bool or mesh boolean. All right, MSH bool. That's what you're looking for. So again, I'll repeat the process. We created a cylinder longer than the lane. We placed in the scene. We put it on the left hand side of the lane, and now we have selected both of these assets. And we're looking for this particular tool set inside the modeling tool, right? MSH bool or mesh bool. So once you select this, you'll see one of them has disappeared. It depends which you selected first. And what we are trying to do here is use the shape of the cylinder to carve out a section of the lane, not the other way around. Like, we're not trying to create a section out of the cylinder from the shape of the lane, not that. We're trying to do the opposite, right? So you'll either use A minus B or you'll use B minus A, but the idea is to receive this preview output. And at this point, you can always select the cylinder and reposition it if you want to, just to be able to see the preview of what's getting what will get cut out. All right. So this is basically the negative result of what will happen if we use one shape to create something out of the other. All right. So you should get this preview, and once you have this, you can now go all the way down, and you can either delete inputs or keep both inputs. I'm going to choose keep inputs, and the reason behind it is because you can keep last input, depends on what you have selected last. And the reason why I want to do this is because if I don't do it, it's going to delete the cylinder, right? So you can keep inputs, and this will keep everything, and you can delete whatever you don't need. All right. So press accept, and if you select the cylinder and move it out, you'll see that the initial lane is still there. If you delete that, you'll have the one which is carved out. The idea to keep all of that exists so that you can reuse the cylinder. Otherwise, it'll delete the cylinder and you have to do it again, right? So let's place it on the other side. All of you are following along with me. Anyone having any issues? You want me to repeat any more steps? You want me to go slow? I can definitely go slower. Just let me know, all right? I'm sure nobody wants me to go faster. I can't see you guys, so if anyone from there can tell me what everybody's status is.
There's a question for you, Rajdeep. Just 1 minute.
Okay.
Sorry, hi, can you hear me? Hello?
Yes.
How's it? So I actually missed the part when you got the cylinder in half. Sorry, can you please repeat that?
Sure. So we're going to do that for the right hand side again the same way. So you'll get the steps exactly the way we did it.
Okay,
so I'm just going to place this cylinder again on the right hand side. And what we are trying to do is carve out the negative space on the lane from the shape of the cylinder, right? So in order for us to do that, we select the two meshes which are involved in this process, which is the lane and the cylinder. And then we are looking for the mesh bool operation inside the modeling toolset. This is the icon. It will be under the poly model category. You see there is a shapes category and a create category, and then below that there'll be a poly model category. We are looking for the mesh bool operation inside the poly model category. That's what we're looking for. So once you select that, it gives you a preview. It may look like this. We don't want to carve out a shape of the lane from the cylinder. We want to carve out the shape of the cylinder within the lane. All right. So it should be the opposite, which is either, depends on how you selected the items. It can be A minus B or B minus A, which is the first option that you get. You select that. And then now at this point, you can reposition the cylinder a little bit, and that gives you a preview. You see, I get a preview. And that preview will be able to tell you if you're doing things right or not. This is what you should be able to see. The shape of the cylinder carved out in the lane. So we did that once on the left hand side. And now we are doing it on the right hand side as well. Are you able to reach this point? I can't see you, so I'm assuming yes. All right. So once you reach this particular modification of the lane, you're good to go. All right. And at this point, you should press accept. But before I press accept, I'm going to go all the way down on the modeling tools options, the details section where I change all the values and everything. The last option that says keep inputs, I'm going to change that back to delete inputs. And the reason behind it is because now I don't need to retain that cylinder anymore. I'm done with it. I can now use the modified new asset and go from there. Okay. So change it to delete inputs and then press accept, and there you go. All right. So this lane is complete. It's entirely made within the engine, and I'm going to go ahead and apply a material on this lane just so that it looks anything different from the basic world grid stuff that it already has. And you know, bowling lanes are made out of a special wood that, or I'm not entirely sure, but it looks wood to me. Even in the preview, if you check it out, the preview is a wood. All right. So what we are going to do is make use of the starter content that is present in this project. And starter content is basically a bunch of stuff which is already packaged with any project in case you need to prototype something, you're not running around on the internet trying to download assets and basic stuff. So that's what starter content is. And we're going to go into that starter content folder and then look for the materials subfolder. And there's a bunch of materials inside there. And right at the end of that collection, you'll find some wood. And I'm going to use this one, which is oak, m_wood oak. And you can just literally drag and drop it on the lane and it'll apply that material. But you can see it looks like the material is pretty scaled up, as in it looks like I'm looking at it from a distance of a centimeter. It looks very large. The texture is scaled up a lot, and you can fix this by going inside the material, but we don't want to do that, because what this tells you is that the UV of this asset is messed up after we made that Boolean operation to carve out the lanes or the gutters. That messed up the operation. Or when we created the lane, the UVs were not set properly. And again, this would be something, you know, back in the day, this would be something that you would have to fix from a modeling software. So you'd have to take this asset back into your modeling software, or you go back to where you brought this from and you fix it and you bring it back into the engine. But we don't have to do that anymore. You can fix something as simple as fixing the scale of the UVs right from within the engine. What we are going to do is again use something inside the modeling tool set. This time we're going to scroll all the way down and we are looking for the UV section. I think it's the fourth last option. That section should say UVs. Okay, and within that section there is an option called project. It's basically going to project across the entire mesh in whatever mode you want, like plane, cylindrical, or cubic, and it'll reassess the UVs and give you a new set of UVs. All right, so I'm going to select project, and doesn't matter what is the setting right now, if it looks okay or not. I wanted to check if the projection type is plane, box, or cylinder. You should be selecting box. Okay, I'll repeat what I've done. Select the asset, go to the modeling tool set, scroll all the way down to UVs. We are using the project operation from the UVs section, and I'm changing the projection type from plane or sphere or whatever is there to box. Okay, and right away it should not look correct And the reason behind it is because there are some values which are set in the dimensions, and I don't want those values. They can literally be 0, 0, 0 for all I care, right? So I'm going to reset this. I think it'll be reset to 100, 100, 100. Okay. And the moment you do that, this looks fine. Yes, the texture has a little bit of, grunge or dirt or whatever you want to call it, some little bit of, detail on it that doesn't make it look quite polished, but that's fine. We can do with it right now. But the moment you reproject the UVs using the box projection type and your dimensions are reset, it should look fine. Okay. And once you're happy, you just press accept and you're ready with the lane. That's the first aspect of creating or getting the basic foundational structures right. All right. Now, once you have your lane ready, the next thing is the end portion where you have all the pins set up and where the pins can go once they drop off. So it's not absolutely necessary that we create it right now, but you know what, let me know if you guys have reached this point. If you have, we can proceed to the asset import side of things, where we import a bowling ball and we import the pin and we get them ready. Does anybody have any questions with how far we have reached? Anyone miss any steps? If you have any questions at all, or if you want me to repeat any steps, please feel free to ask, okay? Okay, I'm guessing not. So we'll go ahead and get those two custom assets within the engine. So whenever you have external files that you need to bring in, like the one that I provided you guys with, you need to use the content browser for that. Okay. So you'll see there are a lot of folders already present. We were in the starter content. I'm going to go back to the content folder, which is the main folder. And within this folder, and by the way, save your work, okay? File, save all, saves everything. Shortcut for that, Control-Shift-S, or you can use Control-S as well. Save everything, okay? All right, so we need to import those assets. You can make a folder for yourself over here. You can right click to get this menu and you can choose new folder. By the way, I'm creating this new folder in the content folder, right? So choose content in the content browser and then create a folder. We'll call it imported assets. You can call it whatever you want. Imported underscore assets or assets is what I'm calling this folder. And I'll create separate folders for the separate assets that I'm bringing in, all right? So one more folder, let's call it pin. We'll bring in the pin first. So once you're in the pin folder, you can use this import button. Can you see there's a dedicated import button? Click that. And we can now venture to the folder where you have unzipped the zip file. You will know that where it is for you. For me, it's over here. And you should see the sm_pin.fbx file. Alright, so select that and press open. Okay, you're gonna get this option, this dialog box called FBX import options. You really don't have to do anything except for this right here that says material. In this import dialog box, you don't have to do anything. You don't have to change anything except this last section which says materials. Just change the search location from local to do not search, and the material import method to do not create materials. And the reason why we are doing this is because we do not want the inherent materials that are coming with this asset. We want to create our own material, all right? So that's why in the material section, change the search location to do not search and the material import method to do not create materials, all right? You can deselect import textures as well if you don't want, and press import all. All right, you can get this error. It's not actually an error, it's just a warning. We don't need to pay heed to it right now. Just close this window, and then here's your file. That's the model that we're talking about. You can drag and drop that in the scene, and you'll see that it doesn't have anything to show, as in it's just a shape, and we are going to create the materials for it. Okay, so if you look into the details of this asset, like whenever you select this asset, you'll see in the details panel, it has 2 material slots, and that's done intentionally. So you don't need a dedicated texture file for this asset. You can literally create 2 materials. One is a white material, one is a red material. You can apply it and it'll just work for the pins, as in where it needs to be red and where it needs to be white. Okay, so what we are going to do is within the same pin folder, I'm going to create the associative materials for this asset as well. So you can right click here and you can choose material. We're going to be creating a material for the pin. So right click and choose material, and you get to name the material. So I'm going to call it m_pin, right? Once you're done, you'll get this file right beside the pin model, m_pin, and if you double click that, it'll open up the material editor. So it can be a small window that opens up in front of you like this, or it could be a fully maximized window, depends. Whichever is the case, you can always take this tab and you can dock it like a browser tab. Unreal allows you to work in a browser tab fashion that makes it easy for multiple tool sets to be open at the same time. Okay, you can choose not to do this as well. If it's too difficult, just keep it as is, and we will be working in this material to create the white material for our pin. And it's pretty simple. You see there is a final output node that needs all of these stuff like base color, metallic, roughness, specular, all of that, right? So we are trying to create that very plastic look that a pin has, you know, and for that we just need to hook 2 information. One is the color, and the second is how smooth that object is, which will be plugged into the roughness attribute. Okay, so you can right click on the base color input. You see this node, you can just right click on the base color input and you get this option called promote to parameter. If you do that, it creates another node for you like this that automatically chooses the correct node that goes into base color. It also connects it, and it also gives it a default value, which is a black color. Now if you click on default value, you can now choose the color that you want, right? And I'm going to create white using this slider right here. I'm just going to make it white and then press OK. So now from black it's turned white, and if you move this node aside, you can also right click on the roughness input of the final node and promote that to a parameter as well, and you get another node which is already made for you, the correct node. You don't have to find the correct node to plug it in. It's everything is done. You just need to change the roughness value. You can see on the left hand side you get a preview of what the material is going to look like, and it's looking extremely smooth right now. It's white and that's fine, but it's extremely smooth right now, and that's because the roughness value is 0, as in I'm saying that it's not rough at all. So I need to make it a little rough, so 0.1 for the roughness value. Okay, and that should be enough. Generally bowling ball pins are smooth anyways. Okay, so, and if you wanted to go really specific about your materials, you can actually look online for a scratch roughness map. You can bring that in, you can plug that in, because generally these kind of assets go through a lot of beating, right, over its lifetime. So obviously you'll have some bumps and scratches all over. So if you wanted to make a really good asset, you'll invest some time. Now for the sake of this session, I'm going to keep it simple, but you can bring in a roughness texture which has scratches on it. It's pretty easy to get it on the, it's a simple Google search will give you a lot of free textures you can bring in, or you can use Quixel to get a scratch roughness map as well, right? And you can bring that in, you can plug that into roughness, and you'll get the same result with a little bit more detail. For now, we're going to use a simple color and a value for roughness, and I'll click on save, which is this icon right on the top left side, and that saves this material. And now I can close it, and what I can do, since I've created one master material, this is a master material, by the way, and I have two parameters inside that master material. One is the color and the second is the roughness. It means that from this master material I can create two instances or two children that can have either the same parameter values for those two different attributes, which is one is color and the roughness, and I can also change it if I want. Alright, so basically you have a parent and you can create a child from that parent, and you can give the parameters of that child a change depending on what you want to tweak. Okay, so you can right click on this material and you get this option called create material instance, and the first one I'm going to call it I'll rename this, I'm going to call it mi_white. You can be even more specific, you can call it white plastic or whatever, and nothing has to change for this because this is already white. But I'm going to create another instance from the master material, by the way, not from the second one, from the master material, create another instance, and I'll call this mi_red. And now I can double click the red instance file, and you'll see it's not a fully fleshed out material editor anymore. It's a instance of that master material. It means that it's still a material, but it only has the changes that you have approved in the parent, which is those two parameters. Okay, one is the color, one is the roughness. So I'm going to enable these two parameters and I can change them from here. Now I'll make them red, I'll make the color red, and the roughness doesn't have to change. You can if you want to. Right, save it, and now what I'm going to do is I can select this pin and apply these two instances. Alright, so I'm going to apply the white in the first slot and apply the red in the second slot. You can also apply materials directly on the asset, so you could have done this also, but this looks inverted, so there you go. Alright, so you can see that the slots are actually two different material IDs on the same asset. So that makes it easy for you to not have textures that define the position of those red stripes. So that makes it very easy. Now the second thing that I want to make sure is whether this asset, actually, you know what, we can come to that later. For now, let's check on the second asset. By the way, just save your work. All right, the second thing that I want to check is the bowling ball. Right, so we have the pin, now we need to take care of the bowling ball. So I'm going to go back one folder and create another subfolder here. We'll call it bowling ball. Open it up and do the same exact process that we have done for this pin. I'm going to press import, select the sm_bowling ball in the directory where you have unzipped the files, and open that up. I'm going to repeat the same process for the import options. I don't want to search for any material, so change that search location to do not search. And I don't want to create any materials, so do not create. I mean, we will be creating our own material, we just don't want this to create for us. All right, so and then press import all. You get the same dialog box again with that warning. We don't need that. Close it off. So now we have the bowling ball. So you must have a question. So why did we need a bowling ball model when we could have just created a simple sphere from the modeling toolset? And the reason behind it is very, very simple and very, very unnecessary, which is a bowling ball has these finger grip things. You know, we don't get that from a sphere. You would have to create that on your own, and to be honest with you, that detail will not be visible, but I'm just a stickler, so I made sure that you have that asset. All right, so there you go. So the bowling ball asset is also present, and one of the good things about having these very particular assets already present for you is that you don't now have to break your head finding the exact dimensions for these assets. Okay, first of all, modeling this pin would have taken some time, so you don't have to do that. And also modeling these holes inside the bowling ball also would have taken time, so you don't have to do that. All right, so now the question is, how do we make this bowling ball look like? What do we make it look like? Well, we have a texture for that. So I'm going to press import again, and this time there's a texture that I've selected and kept for you guys. You can select that texture. By the way, you can also drag and drop any of these assets into the content browser. You don't have to go through the import button, but I'm going to select this texture and press open, and you have this texture with you now. And the fastest way to create a material using this texture is if you right click and create a material. Okay, ideally you wouldn't be doing this, because for a well-defined material you would have multiple textures. Okay, we are not trying to go into too many details, so we just want to use a diffuse texture. That's it. In your case, you can use multiple textures. You can use a roughness texture, you can bring in a normal texture map, and you can combine them all inside a material and create something really nice. All right, for now I have only one, so that makes it easy. I'm going to right click this texture and choose create material, and that gives me the option to name the material file. I'm going to call it m underscore bowling ball is bb underscore master or whatever, you know, it's up to you. Open that up, double click that material, it gives you the material editor again. I'm going to dock it on top, and we'll more or less do the same things that we have done with the pinball. You see the texture is now connected to base color. It's not a simple color anymore, it's a texture, and it's very rough. It looks like a, I don't know, granite stone that has not been polished. So we're gonna give it that very nice smooth bowling ball sort of a look, and you can get that from roughness. Just right click on roughness, promote to parameter, and bring it here, and you can just change the value from 0 to 0.1 because you really don't have anything that is that smooth. So anyways, there you go, bowling ball ready. Now you may want to have multicolor bowling ball down the line if you extrapolate this game into something way more customized. Just for that case, you might want to be able to change the color of the bowling ball, and for that what I'm going to do is disconnect this texture by holding Alt and clicking on this wire. Okay, that'll disconnect it, and what I want to do is drag out from the RGB output of the texture and leave my mouse, and that'll give me the option to choose a node from this menu, and I'm going to type HUE, hue, and that gives me this option called hue texture. It's actually connected to the wrong input of the hue shift node. It gives me this hue shift node, so what I'm going to do is disconnect anyways and connect the output of the RGB to the texture input of this hue shift node. Okay, and for the hue percentage, I'm going to do the same thing with every node that we have done till now, which is right click and promote to parameter. Okay, it takes the name of that input and it also gives it a 0 value, which is fine. And then once this is done, you can then connect the result of the hue shift node into the base color. You'll realize in a bit why we have done this. So this is basically all we need to do for the bowling ball master material, and you can save it and you can close this material editor. And this is a master material. I want to create an instance out of this. So right click, create material instance, and we'll call it mi_bb_, this is green, right? So I'm going to call it green. So now you can apply this instance on this bowling ball asset, just drag and drop it, and there you go. But let's say I want to create a variation in color, and I made a copy of this bowling ball, and the easy way to make a copy is you just hold Alt in your keyboard and then drag the asset. That's it. Okay, it makes a copy. So what if I want to make this one pink? I don't want to have to import another texture. I mean, nobody's stopping you from doing that, but it just increases the number of files that your game contains. When you can just simply open up, or you can duplicate this instance and create another instance. And let's say I want to create a purple ball. All right, I'll rename the new instance from green to purple, open that up. And now, since you have structured the master material in a way that you can make that change, you can actually enable this hue percentage shift. And by the way, the value change cannot be an integer, it has to be a decimal change. So it has to be something like 0.2 or 0.3, and you can see the change happening in that preview, right? All right. Let's try 0.6, 0.7. I think 0.3 was fine. All right. And roughness doesn't need to change, so save it. And now you have a different material, right? You could have one more node in your master material to increase the saturation, right? It's a desaturate node. We don't need to go so deep right now. And anyways, we don't need multiple bowling balls anyway. So I just showed this to you so that you can have a different color if you needed to. All right, so we have all the basic assets that we need ready. Okay, there is one more thing that I want to do before we take a break, and then we come back and design the interactivity of the entire mini game, which is we need to have these assets collide with each other. We need to have these assets be able to bounce on this lane and hit something else and collide and make basically be able to simulate physics, right? And one thing that is imperative is for these kind of assets, if you want them to interact with each other physically speaking, like collision and everything, you need to have their collisions proper. Okay, so what I'm going to do is start off with the pin, and you can see the pin selected in the outliner. You can right click the pin, or you can also select the pin and right click it from here also. It doesn't make any difference. And there's an option that you'll see that says edit SM_pin. Okay, click that. That'll bring up another window where you can it's a secluded area where you can edit this asset. Okay, it's the static mesh editor. So you can now dock this tab on top as well if you need to, or you can keep it floating. It's up to you. All right, so what we are going to do is work on the collision of this pin, and I want to see how the collision looks. But because generally the shape of the asset doesn't always turn out to be the collision of the asset. Okay, always keep that in mind. If your asset has a very complicated shape, that may not be the actual collision shape of the asset, right? It's never always like that. It's not a given. So I'm going to go into this lit menu right beside perspective. There's a lit, or you can see that, and you can open up that list and choose player collision. And what this does is this view mode lets me see the collision of this asset. So press that, and you can see it has this basic capsule like shape. Okay, it's actually a little more complicated than capsule. It has a very particular shape. You can actually keep this shape if you want to. It's actually fine, but in case I wanted to do more, you could always remove this collision and do a sphere simplified, or actually in this case it's not a sphere. You could do a capsule simplified collision. or you could do a 26 DOF simplified collision. All right. So in case your asset did not have a collision, you would have to fix that. All right. So looks like the pin is fine when it comes to collision. Let me just check. Yeah, everything seems to be fine. And we need to check for the bowling ball as well, because that's the one that we're going to launch, right? And that has to hit all the pins. It needs to have collision as well. So right click on the bowling ball, edit SM_bowling ball, dock it on top like this, and just check the player collision option. And this one seems to have a little bit of a problem. So you see, the physical shape of the ball is pretty smooth, right? But the collision is not as smooth. It shows up pretty rugged. And something as smooth as a bowling ball should be able to just glide through the lane without any obstruction. But if your collision looks like this, it'll really bump around, and you won't be able to make precise contact with the pins, right? So we need to fix this. So we'll go up to the collision menu on top and then remove collision, because we want to remove the existing collision, right? Select remove collision and you'll see the collision view disappearing, and then go back to the same collision menu, and this time we're going to add sphere simplified collision. What this will do is approximate the shape of the sphere and give it that exact same spherical collision, right? So just press add sphere simplified collision, and there you go. That makes it a smooth spherical collision object. All right, it should look smooth like this. Just press save to save the changes you've made, and that's it for now. Your assets are ready, your collisions are ready, your materials are applied, everything that you need to be able to visually prototype what you're trying to make here is all ready. Okay, what comes next is the interactivity side. Like, all of this will not make any sense if you don't have any interactivity associated with this, the whole thing, right? And that goes into a little bit of a visual coding or visual scripting side of Unreal, where you will be working with blueprints to get the best out of what we need. Actually, basically create gameplay abilities or gameplay options, right? Where we are the player, we launch the ball, the balls get hit, and then the pins get hit, and then the number of pins that fall is the number of the amount of score we get out of 10. All right. So I guess we can take a 10 to 15 minutes break now, and then once we come back, we'll work on the interactivity side. Anybody who has not reached this point or has any questions up till now for with regards to anything that we have done, feel free to just ask. Anybody, any questions at all? All good with everyone? I can't see you guys, so if you do have questions, maybe ask for the mic. All right, I'm assuming everybody is reached this point. You don't have any questions. I think we can take a 10 minutes break. Sachin?
Yeah, we can.
All right, cool. Let's take a break, and once we come back, we'll continue from here. All right. Hey, is everyone back? Just I can't see you guys, so just let me know if everyone is back.
I know the guys are not back yet. There's only 3 people back.
Cool, no problem. I think we can wait for a little bit.
Is everyone back yet?
Yeah, most of the people are back. The power just went off here, so they're just going back. The computers are just switching back on again.
Oh, okay. Just let us know when we can resume.
Yeah, I think everybody is ready to start now.
Right. Sachin, can you speak? I have just checked my speaker system.
Hello, Tess. Can you hear me?
Please give me 1 sec. Say that again.
Can you hear me now?
Yes, this is better. Yes. All right. I think we should resume. Just give me 1 sec. Okay, I think we're good to go. Hoping everyone's back. I can't see you guys, so I can't tell, but I think we can resume now. All right, so when we left off, we had the assets ready. We imported the custom stuff. We made some stuff that we can't get from an external asset. We modeled it.
As if your mic is a little
low.
It seems as if your voice isn't coming through your mic.
Just give me 1 sec.
Or is that just for me? I think, I mean, did you change something or?
How about now?
Yeah, you sound.
Yeah, now it's proper. Now it's proper.
Okay, cool. Zoom doing something or the other. Alright, anyways. So yeah, we'll get to the interactivity part now. We have all the assets that we need. And let's figure out how to get this game running. Okay. So first of all, there's a player involved in this, and the player is you. You'll be controlling the player, and you will be needing to throw a ball in a particular direction. That's the initial requirement, right? So once we fix that, when we get to the second part, which is the pins that need to be struck, they need to have some physics involved. And then the third portion, which is a scoring system, which needs to keep track of how many pins remain, or how many pins are thrown off of that lane, and score you based on that. So let's begin with the player, because obviously the first course of action in the gameplay is you throwing the ball, right? So we'll make another folder. I'm back to the content folder in the content browser. I'm going to make another folder over here. We'll call it blueprints, because we are using blueprints inside Unreal, which is a visual scripting system, which is basically just connecting nodes with other nodes and then get data to work, right? So we're going to use blueprints inside Unreal to create the functionality of the player, the pins, and the scoring system, the three parts of the gameplay, right? Again, it's a mini game. It's not going to have all the bells and whistles of a fully fleshed out bowling ball game, but it will function properly, all right? So first thing first, we need the player, as in something that you can possess to begin playing the game, right? So for that, I'm going to need a blueprint class, and anything interactive, you know, have to start with a blueprint class, unless you're coding. That's something else. Unless you're coding in C++, that's something else. As long as you stick to blueprint, you're going to need a blueprint class. Class is basically a complicated word for a template to choose from, as to depending on what you're trying to create. Okay, so you're trying to create something in the scene that you can possess, basically your player, and that could be either a pawn or a character. We don't need a character because we don't need to walk around. As you can see, the definition says a character is a type of pawn that includes the ability to walk around. We don't need to do that. We don't even need a physical body. We just need the ability to possess something that can throw a ball, or we don't even need a physical form as such. We just need to be able to interact with the ball. So we just need a pawn. A pawn is an actor that can be possessed. So select pawn, and we'll call it BP_player. Okay, save it, Control S, Control Shift S, and then double click to open it up. That'll again open up as a floating window like this. What I want you guys to do is select the tab on top and then dock it with the main window, and that'll allow you to switch between the level and the blueprint. Level, blueprint, level, blueprint, and this way you can continue working. All right, and as a player which is trying to throw a ball in a particular direction, the main factor is the direction first, and then the ball with what force you throw the ball obviously coming after that. But you need to have a direction to begin with, right? And with Unreal, there is within a blueprint you can add a lot of different parts, combine them together to make a special asset. Here we need a directionality. We need the actual ball in here which is to be thrown. We also need some eyes, a set of eyes, or what we call as a game camera, to see through these pawns. So these are the three things we need inside this blueprint to make it into a valid player. Okay, we need to be able to see through this, so we need a camera. We need a arrow so that we know where the ball is going to get thrown, right? And we also need the ball itself, which is to be thrown. Okay, so to begin with, we need a camera. And whenever you're inside a blueprint, you have these I would say tab inside tab, right? So these tabs on top, you have the viewport, which is like the secluded viewport for you to create what you want to create inside this blueprint. And you have the event graph, which is where you code what you need to code. Okay, so while we're in the viewport, you can add some components to this blueprint to flesh it out. The first thing we need is an arrow. So I'm going to click on this add button on the component section and type arrow, and there you go, we get an arrow, and it's already pointing in the right direction. Okay, as you can see, I just don't like the color red. So as long as the arrow is selected, you see its details are being shown on the details panel on the right. And arrow color is right in front of you. So you can open it up and change it to a nice blue, color, which just doesn't scream danger. All right. So arrow, which is set, colors changed. Now, the thing is, within a blueprint, an arrow component is generally used for debugging or for your information, which is not to be seen while the game is being played. Now, we don't need this arrow for that. Now, you could have replaced this with a hand, okay, which is pointing in the direction you want to throw the ball. But the arrow is already there, so we can use that. But the thing is, this arrow is designed to be part of the development, not the game. So we need to make sure that it's visible during the actual gameplay. And for that, we need to select this arrow, and in the details panel, go down. You see under rendering, there's an option called hidden in game. We can't have this hidden in game. Otherwise, there is no purpose of the arrow, right? So we'll uncheck hidden in game, and that's it. And every time you make a change in a blueprint, just like any other code, you need to compile it. So I'm going to press compile, and then obviously you can compile and save, or you can change the compile function to save on compile on success only. That way you can just compile, you can just click compile, and that'll save the blueprint as well, only if it is successful. So you see, you get a green tick, and if ever you make a change, you need to compile again because it has a question mark now. So every time you compile, you get a green tick, you're good to go, right? So as a pawn, you have the arrow, and now I need to have a camera which is placed so that I can also see through that camera and see that arrow, right? So I'm going to add, and make sure you don't select anything while doing this. So deselect everything. So your arrow must be selected. So deselect everything, and then add a camera. Just type camera, and you have two options, camera and cinema camera. We don't need a cinema camera, we just need a game camera. So just select camera, and by any chance, if this is attached to the arrow, you can always detach it by dragging and dropping it on the default scene route. So when I told you don't have anything selected while adding it, it's because I don't want this camera to be part of the arrow, because now if the arrow rotates, the camera is going to rotate as well, because it's not the child of the arrow, and I don't want that. I want the arrow to rotate on its own, okay, and the camera separate from the arrow. And I want to reposition the camera a little bit, something like this, so that I can, and also rotate it to look down a little bit, not a lot, just 10 degrees. That's it. That'll be enough. And you can position it something like this. Something like this. Alright? So initially the camera was placed like this. I just brought it up, rotated it 10 degrees, and that's it. Okay? And that's the initial setup. And I also need the ball. Keep in mind. So again, deselect everything and add a static mesh. Okay? Just go to add, type static mesh. You get the static mesh option right at the end. Okay? Select that. You can also rename it. We'll call it BB, short for bowling ball. Okay? As long as the static mesh is selected, you need to choose what model it's going to load, right? So as you select the static mesh component, you get a slot on the details panel that lets you choose a model. Open that up, and I think the bowling ball is called bowling ball. Just type bowling. You should get the SM_bowling ball as an option. Select that, and there you go. You also have to apply that material we created for that bowling ball. So I think I don't remember the name of the material. Let me just check. We can go back into imported asset bowling ball, and we can also have that selected. I think this is the one. It's called mi_bb_green. and go back to the blueprint, and there's an apply button. As long as that material was selected, I can just apply it from here. Or if you don't want to do it that way, you could open this list up and choose BB underscore green, and you get that option to select. That's it. So now you can see the bowling ball right at the edge or the back end of the arrow. That's exactly where it needs to be. So again, compile to save all the changes, and then go back outside. And we don't need these assets anymore because this was just there for me to show you how they look like. So we can just delete them, right? And we need the player to spawn in a particular location, which is basically at the edge of this playable lane, right? So, and by the way, speaking of the assets which we fixed before we took a break, there's one more thing that you need to fix, which is this particular lane. If you remember, we added collisions to the ball and the pin, but we never talked about the collision of the lane. That is also important because obviously the ball has to collide with the lane and slot into the gutter if the ball veers off course, right? So I'm going to right click this lane, and just like the other assets, I'm going to edit this lane. It's called boolean 2, right? So open that up, and like every time I'm going to change the view from lit to player collision, and you can see that the player collision is actually using the geometry to create the collision for the surface, which is a complex collision. And that's happening because on the details panel, if you scroll down all the way till you see collision, you'll see the collision complexity is set to use complex collision as simple. Basically, it means use the geometry of the object as the collision. Now you might have a question, so why didn't we do the same thing for the pin and the ball? It's because you cannot use complex collision on objects that need to simulate physics like moving, bouncing, colliding. You cannot use complex collision on that. Whereas this lane is not going anywhere. It's staying put. It is just there for you to collide with. It's not moving. We are not simulating physics with the lane. We're not throwing the lane, right? It's just there. So as long as it's static, you can use complex collision as simple, which basically just means use the triangle or the topology of my model for the collision. That's it. So just making sure of that. If that's not the case with you, you have to change this to use complex collision as simple, and then save it. I'm going to move this aside and close this, and back to working with the player blueprint. Right, so go back to my blueprint folder. So I have the pawn ready. Now there are two ways that you can possess this pawn in the game. One, you can drag and drop this in the game itself, and then obviously turn it around because it's facing the wrong way, and maybe push it up a little bit. You can place the blueprint directly like this in the game, and then change the, and guys, don't follow along with me right now because I'm just showing you one of two options. So you can do it this way and then change the details of this player blueprint from the details panel to auto possess player. You have to change that from disable to player 0. You can do it this way. However, we are not doing it this way because we want to follow the gameplay framework which is already in place for us. So what we want to do is use the game mode and choose the possessable default player from the game mode. Okay, you can do it either way. All right, if it seems too complex for you, I'll show you the other method again, and you can do it that way as well. But the proper way to do this is you can create another blueprint class, and this time we'll not choose from the existing common list on top. We'll go to all classes, which is below, open that up, and then search for game mode, and we're looking for either game mode base or game mode, any one of them. All right, I think game mode works. Select that, and
we'll rename this into BP underscore my game mode, right? And once you double click this, you'll see on the right hand side, we don't really need to do anything in the game mode blueprint. We're just using this to input some details. In the right hand side, you'll see that the default pawn class is set to default pawn. We need to change that to BP underscore player. Okay, select that, compile. Again, I'll repeat it. We just right click, blueprint class, look for game mode, select game mode, not game mode base, and then whatever file is created, you name it and then open it up. And in the right hand side, you'll see in the class default section, there is a default pawn class. You change that to your player blueprint, okay, which is whatever name you gave to your player, the blueprint that we were working on with the arrow and the ball, right? So that's called BP underscore player at my end. So I selected that, and now what we need to do is go to window and open up world settings. That'll give us this additional panel, and within here we need to change the game mode override from none to BP underscore my game mode. And what that'll do is the moment this game is this level is loaded, it'll refer to this game mode and see what's the default player that this game mode has been assigned and use that for you to possess. Okay, obviously there is another way, which is you drag and drop this pawn into the game, and then you rotate it the right way, and then you place it like this, and then you go to the details of that pawn, and then you auto possess player. You can do it this way. This is the simpler way, but this isn't the right way to do if you're making a fully fleshed out game. All right, so that's why we didn't do it that way. Now if you're following the game mode method, I'm going to go out of the modeling mode and just go back to selection.
Sorry, hey, can you hear me?
There's a question. Yeah.
Does anyone have the world settings? We don't have world settings here.
All right, so you can go to window.
Yeah, but it's not listed in the window. So under window, we don't have the world settings. Well, at least not on mine. Anyone else? You got world settings. That would do it. Okay, we're sorted. We're sorted. Okay. Thank
cool.
you.
All right, cool. No problem. So just repeating the steps for everyone who's missed the world setting portion. Open up world setting. You're looking for game mode override, and within that list, choose your game mode file, which in my case is the BP underscore my game mode, right? So now within the level, what you need to do is from the place actors panel or this add menu, any one of them, you just search for player start. You're looking for this particular asset, right? Player start, this particular actor. You can drag and drop that right at the edge of where the lane starts. Okay, just be a little precise with the placement. Not below on the floor, on the lane would be better. Okay, I'm gonna go to the top view to make sure I'm placing it right in the center. And this has to be placed properly, otherwise you're starting off in an angle, right, which is not good. So once you place the player start, now whatever the game mode dictates as the player to be possessed, the player start is going to start the player off from that location. So basically what this means is your game mode can dictate you start off with the car as a pawn or start off as a bird in the game. It doesn't matter. But if you place a player start in a particular location, that tells the game mode where to place that possessable pawn in the game when the level starts. Okay. With this game mode, with the player start actor, you see it also has this blue long arrow, which means you'll be spawned here and you'll be looking in that direction. You don't want that, obviously. You want to look the other direction. So I'm going to rotate this 180 degrees the other direction so that the arrow is pointing the other way. And now I'm at the position where I can simulate the game. So you see there's a play button on top, just press play and you're possessing the player. If anybody has not reached this point where you press play and you're not looking through what seems to be the camera of the player blueprint that you created and you can't see the arrow below you, just notify me and I'll help you out. Okay, at this point you should be looking through the player blueprint that you have created. Anybody seeing anything otherwise, just let me know. And if you want to get out of the simulation, just press escape or shift escape. Depends on the editor actually, which is proper. Shift escape, because you won't get your mouse. Like once you start playing, your mouse disappears. And you have to press either escape or shift escape to get out of the simulation, and you're back outside. And as long as this is what you're seeing, you can save the game and you're good to go ahead from here. Now, what is the next step? I as a player am part of the game now. When the game starts, I need to be where I am, and that's working properly. I'm looking in the direction where I need to. Now I need to be able to launch the ball or throw the ball, and for that what I need to do is go back to my player blueprint and start coding. And we were in the viewport all this while. I'm going to go to the event graph. Okay, so go to the event graph, and what you need to do over here is refer to that arrow, and based off of that arrow you will be throwing the ball. Alright, so what I'm going to do is look for that arrow's forward direction, and from that forward direction I'm going to make the ball decide what direction to be thrown at, and that's going to get triggered from my left mouse button. So all of this begins with the left mouse button. So if I click the left mouse button, the ball launches. All right, so you see there are some existing nodes. These are other ways that something can begin in the game, like right at the beginning of the game, or if this actor is being overlapped, or at all times. Event tick means at all times. All right, so we don't really want to use these for now. What we want to do is wait till the player clicks left mouse button. So I'm going to right click here and type left mouse button, and you can set this up in the game's setting, as in the entire project settings, in the input mapping of the game, so that the left mouse button is called launch bowling ball. And then if you do that, then in the blueprint you can just type launch bowling ball and you'll get that trigger. Okay, so we're just trying to save time by not having to go through and do all of that. So I'm just going to type left mouse, and you get this option called left mouse button, and you can see it's a red node with this mouse icon that tells you it's a trigger, which means once the game begins, this blueprint is going to wait till you press left mouse button, and once you do that, it is going to simulate physics for the ball, right? So I'm going to select the bowling ball because that is what needs to get simulated, and drag that and drop it into the event graph. And what I need to do is, the moment a left mouse button is pressed, this particular static mesh needs to start simulating physics and launch a certain direction, right? So first of all, drag a reference to that static mesh. I'm going to repeat that process. Select and drag it like this, and you get a node, and you drag out of the pin, you get a wire, and you type simulate, and you get this option called set simulate physics. I'm going to select that, and you connect the pressed output from the left mouse button to the input of the set simulate physics node. So again, what this set of nodes here mean is, the moment you press left mouse button, that acts as a trigger for a lot of other things to happen. What's the first thing that is going to happen? It's going to allow this otherwise stationary bowling ball to start simulating physics. Now, if I just did this, it would actually just drop because I'm just simulating physics, which will allow gravity to kick in and then pull the ball down. And you can see that in action. Like if I compile this, and don't forget, anytime you make any changes to a blueprint, you have to compile. You go back to your level and you press play, and we can't actually see the ball. So I'm going to reorient the camera of my player a little bit behind, so I can see both the ball and the arrow. And compile again, go back, press play. I can see the ball now. So if I left click, have I not connected stuff? Just give me 1 second. Oh, by the way, this set simulate physics node needs an additional tick. You see a simulate option that can either be false or true. It's set to false right now. We need to set it to true, which is just a tick. And now if I go back to the game and press left mouse button, you see it just dropped. Okay, which means I'm simulating physics for the ball, but that's about it. I'm not giving it any force. And the force actually comes from, we'll set the force, but first of all, we need to know the direction towards which the force has to be applied. Okay, we can't do anything without the proper direction. Like I need to know where the force has to be applied. And that obviously comes from the arrow. That's the whole reason why we have the arrow over here. Later on down the line, we will also make this a little more difficult, because if the arrow is always pointed front and center, you will always hit all the 10 pins. We'll obviously make the arrow randomize its position, maybe add a rotational function, you know, looping function. But for now, we need to just figure out the setup of all of these things, you know, individual components. So we'll keep the arrow straight, and we'll drag a reference of the arrow into the event graph. So just select and drag the arrow, you get a reference. And from this arrow, I need the forward direction or forward vector. So I'm gonna drag the wire out of the pin from the arrow component and just type get forward, and you'll obviously get the only option that you need, which is get forward vector. Okay, this gives you another node. And whenever you use a vector request, you're actually getting a lot of different values, actually 3 values, because a vector for any particular asset has 3 dimensions to it: the X, the Y, and the Z, right? So for now, we already know that the forward vector is one direction only, which is going to be whichever direction the arrow is pointing at. So we don't need to select specifically that particular direction. All we need to do is connect this to another node to the bowling ball. All right, so what we need to do is come back to the bowling ball, and we need to apply a force to this. So drag out from the bowling ball and type add impulse. Okay, you have many add impulse related nodes, like add angular impulse, add radial impulse, or add velocity, add impulse at location. We don't need any one of these. We just need add impulse. Select that, and that becomes the second node in the chain of the left mouse button trigger. First was we set the physics to be enabled for the bowling ball. Second is we need to add impulse to the bowling ball. So again, the target is the bowling ball, right? We'll just connect the chain. So it's a complete chain like this, right? Initially it will be disconnected like this, so we'll complete the chain. And you see this impulse, add impulse node has a impulse input, which has a X, Y, and a Z direction. Now we don't have to choose any particular direction from here, because that direction is going to come from the arrow, and that is already ready waiting for us from the output of the return value from the get forward vector node. We'll just connect that into the impulse input of the add impulse node. That's it. That's all we need to do. And last but not least, just like simulate has to be enabled, velocity change also has to be enabled, right? Velocity change is the option that you get inside the add impulse node. Just tick that as well, otherwise it won't work. Okay, So just to summarize and give you an overview of what we've done, left mouse button is the trigger. The game waits and does nothing till you have pressed the left mouse button. The moment you click that, bowling ball is referred to first because that's an asset that we have used in the chain. First thing you're doing to the bowling ball is you're setting it to be simulated for physics, and then you're adding an impulse immediately after that, and that impulse direction is coming from the arrow. All right, arrow's forward vector. So if I compile this and go back out and play, if I click again, you see it still drops down, and the reason behind it is because right now the ball knows where to go, but that's just a vector direction. But we also need a little bit more velocity to be able to push it or propel it forward in that direction. It does know it has to go forward, but the value is not high enough to push it forward. So what we need to do is, right after we choose the velocity direction, we need to multiply this value before plugging it into impulse. So basically we just need to give it more velocity, that's it. Alright, so I'm going to disconnect this impulse connection. Alright, alt click disconnects a wire, and I'm going to drag out again, and this time I'll type multiply. So I'm going to multiply this forward vector with a value, and in order to do that in the fastest way possible, I'm going to come down on the left hand side to this variable section. Can you see variable on the left hand side? You'll have my blueprint panel, and it has a variable section, and you have a plus icon, which means you get to create a variable of your own. A variable is a changing data. All right, that's it. So press plus and you get a new variable. Just type impulse, strength, or velocity, or whatever. I'm just going to type velocity. You can type impulse, okay, whatever you want. And by default, a variable is always a boolean or whatever the last variable type you selected. We can't keep it as a boolean. We need to open this list and choose float. Okay, float. We've created a variable, we've named it impulse, and we've changed it to a float type variable. Alright, and I'm going to drag this variable out and place it over here and choose get impulse and connect that into this node, and it will automatically convert it from a float to a vector. Okay, so at this point I need to compile. Again, I'm going to repeat the process. I disconnected the forward vector going into impulse directly. Instead, I connected it to a multiply node, and I need to multiply it to a value, and that value is coming from a new variable that I created, and that variable is a float, not a boolean, a float. We changed it from a boolean to a float. Okay, name it whatever you want, drag it in and choose get, so we get this value, and we connected it. And at this point you have to compile before you make any changes, otherwise you can't change the value of the impulse variable. Alright, so compile and then select the impulse variable, and you see in the details panel the default value is set to 0. Anything multiplied with 0 is 0. We are back to where we started. We can't have 0 velocity, so we'll start off with say something like 500. Okay, and then compile again, and then go back, press play, left click, and it's not enough, right? And actually the main reason is because it's not connected, so the output of the multiplication has to go back into impulse, because we have now multiplied the forward vector with enough additional velocity, and then we connected it back to impulse. We'll go back and we'll press play, and you see the ball does go forward. All right, but it's not fast enough. I'm sure you have to be very weak for the ball to just go at that speed. I'm going to try that again, and see it's pretty slow. Let's increase this. Let's multiply it to 1,000. Okay, and then compile, go back, press play, and I think this is a good value to start off with. All right, we can actually increase this a little bit more, maybe 1500, and that would be enough. Okay, not 15,000, 1500, and then press play. I think this is good enough. All right, it seems a little fast to me, like you're a professional player, but it's okay. For now, it's fine. All right, we can slow it down maybe a tad bit, maybe 1300. Right, this would be fine. All right, so now we are good with the physics of the ball, but here's one thing. If I just throw it, just left click once, it throws the ball, and then I escape again, and I play again, and this time I'm going to left click again, and again, and again, and again. So what's happening is, as long as I press left click, it is going to launch the ball again from the point at where it is. So basically, that left click add velocity option is not just happening once when you do it. Even after the ball is thrown and it's on its way, you can actually just left click again and it'll launch again, right? And we don't want that, because you just get the chance to throw it with a particular velocity only once. And that's the key word, only once. So we'll go back to the player, and right after the left click is pressed, I'm going to break this chain and insert one node in here, which is going to make sure that the left mouse button is only clickable once in one round. Okay, so I'm going to bring this, just drag out from pressed, and I'm looking for a node called do once. Okay, there are two options: do once, multi-input. We don't need that, we just need do once. Select that and place it in between. I'm just going to push these nodes away a little bit and then connect the chain. All right, and compile again, go back outside. Now, no matter how many times I press left click, the ball is only propelled just once, which is at the beginning. All right, so that's it. That's the physics side of things. Now we need to kind of randomize the way we are doing things. All right, first of all, I'm having to escape the game and come back again, simulate it, and then again escape, and then come back again, re-simulate the game. Why don't I add the functionality of resetting the level with a button, so that I don't have to get out of the simulation and re-simulate it just to try the game? So you can do that. It's pretty simple. I'm going to use a right click for resetting the game. Okay, ideally you won't be resetting the game. Ideally it would be a more complex setup in an actual finished game, which is when the ball the pins are struck, they're recollected, and then a new level is, or a new round is loaded for you without having to reset the entire level. So that's a pretty complex setup. We don't need to go into that right now. We just need the right mouse button to be able to reload the level for us. So right click to get a node and type right mouse button. All right, so that's what you need, the one below right mouse button. Select that, and it's a simple node that we need to connect this to. So drag out from pressed and type open level, and you have two options: by name and by object reference. By object reference is simpler because it gives you a menu to choose from, and basically what we are trying to do here is open this level again, as in resetting the level. It's pretty simple. So I'm going to open this list, and there's my level, bb_map_1. I'm going to select that, compile, and now if I go back to the game, once I launch the ball and I'm not happy with the results, I can just right click and I'm back to where we started. Right click, back to where we started. Right click, back to where we started. Okay, again, just so you know, I mean, you guys already know this, in a real world scenario or a real game scenario or a finished game scenario, this would not be the case. You would actually progress to the next next chance to throw the ball, or the next round, or whatever, however it progresses, not reset the entire level. All right, we're just doing this to keep things simple for the workshop. Right, so now I have the ability to always come back and throw the ball. But here's the thing, it's not difficult at all, because at this point I can always throw the ball straight because it's dead center straight. and it'll always hit all the pins, because we know if you hit the center pin, it more often than not drops all 10 pins, right? So we need to randomize this movement, but before we do that, I'm going to set up the pins so that we can at least test this functionality if it's functioning properly or not, right? So don't get into complex game mechanics unless you are absolutely sure all the, you know, the pieces, the moving parts of your game is coming together and letting it function properly, right? So within my blueprints folder, I'm going to create another blueprint, right? So I'm going to go for blueprint class, right click here and go for blueprint class. And this time I don't need game mode, I don't need a pawn, I just need an actor, because the functionality of the pin is not to be possessed, and the functionality of the pin is not to provide any gameplay information more than just score, right? So I'm just going to choose actor from the top list. We don't need this one below, just actor, nothing else. It's a simple actor, and we'll call it dp underscore pin. That's it. And then double click to open it up. It opens up in a new window. I'm just going to move this aside. I think I can move it to the other screen. Let's see. No. All right. Maybe I'll just bring this down. Okay. So we are in the blueprint for the pin. It's a fairly simple setup. All we need to do is add a static mesh. By the way, the word static mesh in Unreal means a model, right? A geometry. So I'm going to go to the component section, press add, and type static. I'm going to get this option right at the end in the menu called static mesh, and I'll call it pin. You can name it whatever you want, but I also have to add the static mesh from the details panel. So open this up. I'm looking for pin, and there you go, sm underscore pin. Obviously it has those two materials that you have to add to it. So I'm going to go to the you know what, right within here I'm just going to look for pin. Let's see, yeah, mi underscore white, and I think it's called mi underscore red for the next section. Yes, there you go. The white one is the first material and the red one is the second material, right? This is set. I'll compile. You literally have to do nothing other than this over here. This is it. We're done with the pin. We also don't need to come back to the game mode. We just need to work in the player, if at all. Right? So we'll come to that later. Now I need to place the pins on the end of the lane. I'll place one, and then I'll go to the top view to make sure that it is more or less in the center. If these icons of these assets are bothering you, then you can always just go back to the main perspective view and press G. G basically lets you look at your level the way it would look once you start playing the game. It's called game view, right? Game mode view, right? So just press G and then go back to the top view. I'm gonna select this pin, and I'll also just make sure that it's flush on the ground. And you can do that by dragging it up like this and then pressing the button end on your keyboard. You know, end right below home, around the arrow buttons, just press end and it will just place it flush to the ground. Okay, this is just to make sure that it's not under the surface, right? So I'm going to go back to the top view and I'll make copies, and there's a particular structure in which bowling ball pins are placed, and I'm going to follow that structure. You can follow that with me. At the end of the day, there has to be 10 pins. So 1, 2, 3, 4, 5, 6, and then one more set at the end. I can already see a problem. The problem is, for the next pin to work, there's not enough space. So I can work with the lane. I can just widen the lane a little bit. I can do it from outside as well, like from here, or I could do it from the top view. I'm just gonna scale it up a little bit more. Okay, just a tad bit more. And if your scaling is snapping to a particular size, you can disable it from here and be precise with the scaling. So you can disable this and then scale it again. Sorry. I think that's good enough. And I can go back to working on the pins. I think I need to bring them all forward in order to make space. I think 5 is not enough. I have to be even more precise. There you go. All right. This is better. Yeah. So this is the pattern you're looking to make. So you have 1 in front, then 2, and then 3, and then 4 at the very end. That makes it 10, all right? So 4 plus 3, 7, plus 3, 10. Okay? This is the pattern that we're looking at. If you want to be exact. If you don't want to be exact, that's on you. All right? So pins all placed. The lane is slightly widened to make room for the last pin on either side. And just to be sure, we can always go to change my view from lit mode to player collision, and you can see all of them have collisions, right? So now what I can do is go back to my play mode and press play and wait for them to get hit. And the thing is, they have collision, so they are reacting to the ball, but they don't have physics being simulated for them, as in they're not ready to be dropped or thrown around. So what we need to do is select all these pins and go back to the details panel. Actually, you know what, we can do it right within the main blueprint. In your blueprints folder, open up the pin blueprint, select the pin static mesh in the component, and you're looking for the simulate physics option in the details panel. Again, I'll repeat, we don't have to do it to all the pins, we just have to do it to the parent blueprint, which is the BP underscore pin. Double click that, open up, and select the pin from the component section, which is the static mesh, and the details panel, you're looking for simulate physics and tick it. Okay? Compile. You can select your own weight for that pin, like you can make that pin say 5 kgs, 10 kgs, or whatever. You can change the unit of mass also if you're working in pounds or whatever. Let's close this and go back. Let's press play. Try this again. And there you go. It works, right? So what I feel is that first of all, my view is pretty narrow. Sorry, it's pretty wide. So the pins are pretty far and I can't see. Now you can make this into a very complex setup by which the moment I left click, there's a zoom that happens on the pin. You can do it, but it takes a little more complex setup, all right? So we can avoid that for the sake of time. And what we can do is go back to the player blueprint. If that's not open for you, you can go to your blueprints folder, double click BP underscore player, and you can select the camera actor. And what you're looking to do is reducing the field of view. Okay, so drop it from 90 to 70, and we'll keep reducing it and repositioning the camera. Just press play, and you can see now I can see more of the end of the lane, but I can see less of my the bowling ball and the arrow. So what I need to do is go back, stop the simulation, by the way. Anytime you want to make a change, it should not happen while you're simulating the game. All right, always stop the simulation and then go to the player, and then I'm going to go to the viewport of this blueprint, and I'm going to move this camera back a bit. Okay, so I can see more of what's in front of me as well as far away, and I can now reduce the field of view to 60 as well, and then compile, save, and try playing. I think it's too far back, so this is a trial and error process. You'll have to keep doing this till you get it right. I think this is again taking up too much space, so I'll stop it, bring it closer, maybe reduce my field of view even further, like 50. And I think this is fine. I think it does need a little bit of repositioning. Again, it's up to you how you want to do this. All right, so that's fixed. That's fix number one. And fix number two is I feel that my bowling ball does not have enough mass to bring down all the pins. Like you can see that right now, even with perfect direction, perfect center hold, it's still not dropping all the pins. And the main reason is because the bowling ball does not have enough mass compared to the pin. So I'll select the bowling ball static mesh component inside my player. And in the simulate physics section, you'll see there's an option to change mass. You don't need to take simulate physics. You can let that be because that's happening in code here. So you don't have to enable it here. But what you need to do is change mass. So right now it's 3.4. I'm going to enable this and change it to 10. Okay, so it's 10 kgs right now. It's a pretty heavy bowling ball. So I'm going to try playing again, and this time I think it'll drop everything. That works fine, right? So now the relationship between the mass of the ball and the pins looks like it's proper, but again, you might need to fine-tune this if you work further in this direction, right? So again, everything is set properly. The ball works, the pins work, all good. Now the only thing that remains, well, there are two things that remain. One is the ability to let the player choose or be able to have some challenge to the throwing portion, right? So it's always throwing straight. So what I'm going to do is, instead of letting the ball always be thrown dead center straight, I'll add some randomization to the movement, or not randomization, I'll just have the pin moving or the arrow moving so that you have to actually precisely time yourself right to center throw, because you always have to dead center throw to get all the pins, right? So you can do this with another node in here which is already present, which is called event tick, which means at all times. And at all times, what I want to do is run a loop of a curve, okay? And that curve I'll design using a node called timeline, right? So I'm going to drag out from the event tick, and I'm going to type timeline and get this last option called timeline. And what I'm doing here is just designing a curve over time. That's it. It's a simple curve over time, which is going to decide how the arrow is going to oscillate, right? So I'm just going to call it curve or wave or whatever, you know, and then double click this node. Double clicking a timeline node opens the timeline, and you can see that it's empty right now because it has no track, and I need to add a track, and I'm going to add a float track because that's the simplest to do. And we can name the float track whatever you want. Let's say oscillation, if I get the spelling right, I don't know, right? So whatever, you can name the track whatever you want. And now you have a track in the timeline, but it has no data, as in it has a flat line. How do you make changes to this line? It's pretty simple. You add keys at a particular time and add value to that key. That's it. So you hold shift on your keyboard, okay, and you left click, that adds a key. So the first key will begin at time 0, or you can start actually time 0, and the value can be -1. All right, and you can see that the key has gone below. You can actually move the timeline using your right mouse button, and I need a second key, which is say at time 0, or you can just shift click again, you get another key, and I'm going to time it at say 1 second and value to be 0, all right? Or, you know what? We can time this to be at 2. Let's try this out. We'll fine tune it, and value to be 1. Okay. And then one last key. So shift click again, and this time at 4 and value at -1. So it makes a complete oscillation from -1 to 1 to -1, and then this whole thing needs to be a loop. So the entire duration of the timeline is 0 to 2 to 4 seconds, and you see the length is actually 5. You see the timeline length by default is always 5 seconds. I'm going to change that to 4, and then also press this loop. You have to enable loop. So what will happen is this will loop from -1 to 1 to -1, and then start again from -1 to 1 to -1, right? So it's a complete oscillation. Now it's a linear oscillation like this. You can refine it by selecting all of this and changing them into Bezier curves like this, right? By selecting everything, right click and selecting auto. You can do that. You can flatten them as well, and then go back to the event graph, compile it once. If anybody wants me to redo the curve section, just let me know. All right, all I did was in the event take, I added a timeline node. I'll do this again, and then name the timeline, open it up, add a track which is a float track, name the track, add a key, give it time 0, value -1, add another key, give it time 2, value 1, and then another key. You can zoom out with your middle mouse scroll, and then add another key, and then time 4, value -1 again, and then select all of this, turn it into actually no, reduce the length of the timeline to 4 seconds, loop it, and then right click, auto, right click, flatten. That's it. Few steps. That's it. I made another timeline for no reason. I'm just going to delete it. So all we need to do is make sure the event tick is connected to this timeline input of play, and what I want to do is constantly have the relative rotation of the arrow keep changing. All right, so I'm just going to bring this arrow up a little bit, drag it from here. You see the arrow reference where we got the forward vector. You can use the same reference. You can again bring another arrow reference if you want. It's not a second arrow, it's the same arrow, right? Or you can drag out from the same one if you don't want to. If you want to keep it clean, you'll get another arrow reference, or you can drag out from the same one, and you can type set relative rotation. Type set relative rotation, and you should be getting this particular node, set relative rotation. All right. So once you get that, connect the update output from the curve into the input of the set relative rotation. And the relative rotation's target is the arrow, because obviously we want the arrow to keep rotating, right? So at this point you are rotating the arrow, but if you remember the keys that we added in the curve, it's going from -1 to 1 to -1 again, which is in degrees, it's very less. It's basically just a 1 degree or 2 degree difference. We need to multiply that, say 50 times to get a 50 degree of difference. We need a lot of movement in the arrow, because if we just move it 2 degrees, then it's fairly easy to get a straight shot, right? So, and the track that we created is an output from the curves node, the timeline node. As you can see, oscillation is what I named that track. So I'm going to drag out from there, and actually before I do that, I'm going to right click the rotation input of the set relative rotation node, and I'm going to split it, because I actually just want to rotate the z axis of this arrow, just the z. I don't want to roll it, and I don't want to pitch it. I just want to rotate it on the z axis. That's it. So if I would have just connected it to the direct input, it would actually rotate on all axes, so it would have done something like this. So you don't want that, right? So I'm going to split it so that I can connect the oscillation to only the Z input. And before I connect it, I want to multiply it to 50. So drag out from oscillation and then type multiply and then add a value 50 and then reconnect it to the Z input. Z, okay, which says yaw, Z input to the set relative rotation whose target is the arrow. Now since the arrow's forward vector is constantly changing, the ball will get thrown at the direction during which you left mouse button clicked, depending on which forward direction it was facing, right? So if I compile this, go back, press play now, you'll see that it's rotating, okay? And I think 50 degrees is a lot. So what we can do is let's reduce this to 30, compile and press play. 30 is good. And if I try to time it right, I'll get it. Right click again to reset the level. I'm apparently very bad at this. Okay, so the gutter caught it, but then you can see that the gutter, even though the gutter caught it, the ball is actually hitting the pin, which is not a good thing. We need to expand the lane a little bit more, just a tad bit more. So I'm gonna just expand it a little bit more, try to throw the ball at the gutter and see if it touches the pin. Yeah, it shouldn't touch the pin. There you go. Now I'll try to center throw the ball. So it was almost a strike, right? Reset again. And you must be wondering, so what if players want to goof off and throw it outside the map every single time, just for the heck of it? How do you prevent them from doing that? Like, obviously players will keep goofing up, right? What if they keep doing that and make a nuisance out of your game? Well, you can prevent that from happening by placing something called blocking volumes on either side of the lane, right? So what I'm going to do is go to the place actors tab and type blocking, and I need this blocking volume. Drag and drop that in your level, and it'll be like an invisible volume. All you need to do is make it the right size, okay, like this thick. I don't think you guys can see it, it's pretty thin, right? And what I'm going to do is go to the top view, look for my volume and place it right at the edge of the lane on either side. And I'm also going to scale it so it stretches all the way from the beginning to the end, and a little more, with a little more margin as well, okay? And you can hold Alt and left click drag to copy it, to put it on the other side, and there you go. So you have invisible walls preventing your player to goof up your game, right? So make a mockery of it, right? So now if I go back and try to throw it outside, you see it'll get blocked. Obviously in a real world situation, if you try to do that, you're actually ruining someone else's game and you get thrown out of the arena, right? So that's not going to happen. But at least in the game, I mean, you lose some points or you foul or you get disqualified or whatever, but then at least for now your ball's coming back to the lane, right? This could be misutilized. But all right, let's try to throw it at the pin. So it looks like the functionality is working. Now the last piece of this entire system is a scoring system. Now if I don't keep score, why are we playing at all, right? So that's the last piece of this puzzle. We need to make one more blueprint, which is to do with scoring the player. Otherwise the player has no motivation to keep playing, right? Obviously you want to keep score, your friends want to keep score, if at all everybody else wants to play or whatever, right? So we need another blueprint for that. That will communicate with how many pins have fallen, right? So for that, I'm going to right click in my blueprints folder, create another blueprint class. I'm going to select blueprint class and choose actor, and we'll call it BP underscore scoring system or whatever you want to call it. you must have noticed I'm trying to name everything with a prefix like BP or MI or M or SM, and that's because you need to keep track of what kind of asset it is, and it's always good to have a nomenclature system doing that for you so you can recognize it immediately. Okay, so this is BP underscore, which means it's a blueprint if you didn't know the icon, right? So anyways, I have the blueprint. What I'm going to do is directly place it before making any changes in the blueprint. I'm just going to place it right in the dead center of the pins. Okay, I just want to make sure it's right in the center of the pin layout. And the reason why I'm doing this is because while I build this in the blueprint, I also want to see how it looks like in the level, right? That's why I've done this. So I place it, even though it's empty, I place it in the in the middle of all the pins, and then I open this blueprint up, and the first thing that I want to add in this blueprint is a collision box. And the reason behind it is because this scoring system, by the way, is not the only way that you can score or keep track of the score. This is one of the ways, and by far the simplest way that I can demonstrate in the session. That's why we're doing this. There are many other ways that you can find out how much you've scored per round. Like you can also keep track of every pin's orientation. So if it's not straight and it has tilted, obviously it'll fall off. So, and if it's fallen off, it'll never be like the straight rotation of the pin. So you can always track each pin's ending rotation after like 1 or 2 seconds or after 5 seconds after throwing the ball. If it's not straight, it means it has fallen, and you count that, and how much ever is left is or how much ever has fallen is the score. So that would be the most flawless way of calculating the actual score. The other, which is what we're doing right now, is placing a collision box right at the head of all the pins, and when the head moves off from that collision, it means that it has fallen or tipped off, right? Which means you've scored. So I'm going to add a box collision, and while I'm doing this, I'm going to undock this window so that I can have a look at the map while I'm doing it. And the idea is to scale this just enough so I can keep track of all the pins and not more or not less, right? And it has to be just thick enough, like this much, and also thick enough or wide enough to contain all the pins, so which looks like it is. And what I'm going to do is compile it. It's fine, and I'll bring this blueprint up. I'll use a different view mode like right or left or whatever, and make sure that only the bottom portion of the collision box is barely touching the pins. Like not like this is too extreme, maybe just like this, right? Because a moment a pin tips off, it's not inside the collision box anymore, and that's how I'm going to figure out how many pins are standing and how many pins have fallen. Okay, so, and you must be wondering, okay, so what if it moves out like this? Well, it's rarely so that the pins would have moved out so much in front and not have fallen. So it's pretty rare. As I mentioned before, this is not the only way that you can keep score, but this is the way that is the least complicated, at least for now. Okay, so I don't need to do anything to the player blueprint, so I'm going to shut that. I want to open up the scoring blueprint, so I'm going to dock it on top again. And what I want right now is this box to keep tabs of, what is this? No, this box, this collision box, to keep track of how many of the pins have stopped overlapping with it. Okay, again, I just want to keep track of how many of the pins have stopped overlapping with it, which is ending to overlap, right? That would be a trigger for me to count. Okay, so 1, 2, 3, 4 pins have fallen, right? So how do you do that? You select this box, and in the details panel, it's a collision box. Okay, so I'm just calling it box, and in the details panel of that box, you come all the way down, and you have this section called events. And in here, you're looking for on component end overlap. not begin, end overlap, as in I'm looking to see how many pins have ended the overlap with it. All right, so that's it. On component end overlap. So select that, and that becomes a trigger for you to begin. But then, what if other things stop to overlap with it? Then it'll also start counting other stuff, right? We don't want that. We just wanted to keep track of how many of the pins have stopped overlapping with it. That's it. Which means that the other actor, not itself, the other actor, as in the pins, which is what we want, should be the pins, right? Not anything else, not like the ball, not like some other player that has fallen into our lane. Okay, we don't want that. We just want the other actors to be the pins. So drag out from other actor, not other comp, not overlap component, other actor. Okay, drag out from that, and you're looking for this node called get class. Okay, why? Because I want to look for that blueprint class, which is BP_pin. If it's not that, it's not going to go forward. All right, so other actor, get class, and it'll return a value of all the classes, and that has ended the overlap with it. And I want to make sure that it is equals to, as in I just type the equals to button on my keyboard, just equals to, and or you can also type equal. It's the same thing, right? So equals to, you get the first option, which is equal, and you can select the pin from here in this menu. So open up this menu, type BP_pin, you select the pin, and it'll make sure that the other actor is the class of this pin. And from the output of this check, I want a condition, and only if this condition passes, we're gonna go and add to the scoring system. That's it. So drag out from this red output of the equals to node and type branch. Okay, and now you see the branch has an execution input, which means I do have to complete the chain. Okay, I do have to complete the chain. It's not just going to take a condition and go forward. It has to be triggered. So I'll trigger it, and if it's the pin that is getting end overlapped or whatever, the true output will fire. If it's anything else, like obviously the ball is also going that direction, right? So if it's that, it's not going to count. If it's true, what I need to do is I need to store the number of times this happens in a variable. That will be the main scorekeeping variable. All right, so I have to create that variable. So come to the My Blueprint panel, down to the variable section, you get a plus icon, create, press plus and type scorekeeper. Okay, just type scorekeeper, and obviously we can't keep the boolean as a variable type. I need to change this. Now remember last time we created a variable just like this and we chose a float as a type. The reason why we are not choosing float again as a type is because we don't really care about the decimal value of a score. Like, what if I tell you this round I score 4.5? What does that even mean? Next round I score 8.1. That doesn't mean anything, right? It's either 8 or it's 4 or it's 0 or it's 10, which is not a float. It's an integer. Integer is a whole value. It doesn't have any factors to it or decimal to it, right? So select integer as the type and compile, right? Compile, and then we'll get the variable outside. As you drag it, you get this option to get or set. I want to get it first, okay? And what I want to do for the scorekeeper value is I want to keep adding to it as many times the true is fired. And how many times will the true fire? Every time this end overlap box is triggered and the class is the pin. Obviously the pins are the ones which are going to drop. So every time the true is fired, I want an increment in the value of scorekeeper. By the way, the scorekeeper integer value by default you can see is 0, which is okay because our score starts with 0, right? So I'm going to drag out from scorekeeper and type plus plus. Okay, the symbol addition plus plus, and that gives us this node called increment integer, or you can also type increment. Easier is plus plus. Just type plus plus like C++, plus plus, and you get this increment node, and I'm going to connect it to true. And what happens is every time true gets fired, this keeps increasing in value. Okay, and that's not enough. Having this is great, like, but you have to display it as well, right? So I'm going to undock this blueprint once again and go back to the perspective view of my gameplay here, the level. And what I want to do is I want to display the score. So I need some kind of text. Okay, so I'll add a component text to the scoring system. Just type text and you get this component called text render, and I'll call it the score. Okay, you can choose not to name your components also, it doesn't matter. Okay, it's just to keep track of things. Now I'll select the score, and in the details panel, and the reason why I've undocked this window is so that I can see what I'm doing, right? In the details panel of the text render component, I'm going to come down here and look for horizontal alignment, and that's left aligned. I'm going to make it center aligned, and I'm also going to change the text color by default to be red. Why, you must be wondering? Well, if it's 0 by default, it's red, like you've done nothing. So red, red is usually used as a sign that you've lost, like sort of like that. Okay, so by default color red, it's it's center aligned, and you will also get the opportunity to change the text as it says by default. You can see there's a box that says text right above the material, and it also says text, as in it is text and it says text. I'm going to change this to score colon. We can keep it like this for now, right? Score colon. And I just wanted to see how it's shaping up. I'm going to go to the viewport and push this up a bit so it's right over here. Okay, and compile it, and now I can go back to building my code again because I just needed to see where it was, right? You can also bring it in front like this, slightly in front, and then go back to the event graph. So see, now what I want to do here is always keep track of how much the value of this scorekeeper integer has changed, and based on that I will set the text again. All right, so what I need to do here is drag out from scorekeeper. Actually no, I need the score as the text because that is being changed. So I need that, the score, the text, and I need to set the text every time the scorekeeper value has changed. So set text, and you get this set text node, not material, not render color, set text, and I'll connect the chain, but then the value has to come from a text. So it's not just, the whole text is not just a number, it's also SCORE colon and then something else, right? So it has to come from text. So I'm going to drag out from value and I'll type to text, okay, or just type text, okay. And actually it has to not be to text name, it has to be to text string. So type to text string, and you get this to text string as a node, right? String is a collection of letters, and again that's not a entire sentence that is changing. The portion of that sentence which is SCORE colon is never changing. The thing that comes after it, which is the value, that is changing, but the input is only one. What can I do with that, right? So I need to append this. You right click this, actually no, you drag out from here and type append, and what this append node allows you to do is keep one which is A, and you type score colon space in A and you change B, B becomes the value which comes after score. And again, that will, wait, we need to make some space. Let's push this aside. And what you need to input in B is after the increment that is happening. So as scorekeeper gets incremented, it will keep adding to B. And the moment you connect the increment output to B, it changes the type from integer to text string, as in it is a value, but it needs to be in the form of a string. So it automatically changes that. Anybody stuck right here because it's a complex calculation we just did? It's not really that complex, but it's a lot of node. Anybody who couldn't follow or need explanation as to what we did? Don't forget to hit compile. Everybody able to follow up till now? I'll just go through this once again. So every time a particular class of actor, which is the pin, ends overlap, there's a condition which is met, and if it's met, we have a value called scorekeeper that will keep increasing with the increment node. And there's a text which will display that value, and that will change every time it's incrementing. And that text has two parts: A, which is never changing, which is score, and B, which will contain the actual score value. That's what we are doing through this collection of nodes. All right. So we also want to do one more thing before we at least finish up the scoring system. Let's just see whether it's working or not first. So let's play and try to hit this right. And I'm bad at this, so I'm going to reset. And I'm going to reset again. And there you see, it works. Score 9. I'm just going to bring that text down a bit. I can also increase the size of the score so I can see it better. Compile, press play. I'm really bad at this game. There you go. It works. Okay, I'll try to hit all of them. Close enough. And there you go, 10. That counts as fallen, okay? Alright, so this clearly works, but obviously I can't keep the text looking red. So what I'm going to do is have one last piece of code over here and check whether that value is equals to 10, and the moment that value is 10, I'm going to change the text color to green, as in you got the full score, right? So I'm going to drag out from scorekeeper, and I'll make sure it's equals to the value 10, and drag out from this and type branch, connect the output of set text to branch. Okay, if that condition is met, I'm going to change the score's text color. So drag out from the score and type text color, and you have this option called set text render color. Connect it to true, and the value needs to be a variable. So I'm going to right click on value and type or set promote to variable, and it will come up over here in your blueprint my variable, or sorry, my blueprint variable section. I'm going to call it text color green. Okay, it's the right variable type, so you don't have to change it, but you do need to compile it before you change it to green. So compile and then select this node and then change it to green or whatever color you want. Compile, and now if I go back, it will be difficult for me to hit a full 10. Let's try. please fall. There you go, 10. All right. So my entire system works now. You have a way to reset the rounds. Obviously, it's not keeping track of each round's scoring system, and we can't even achieve that within the time frame that we have. Three, okay. Why am I so bad at this? You know, you create a game and you're bad at your own game. This is that. And there you go. All right. So again, just to reiterate, this is only one way of creating the scoring system. There is another way. You can have a collision box. I'm not going to make that. I'm just going to tell you about it. You can create a collision box like the one we have on top on the pins. You can have one behind, okay? And every time a pin falls in, you calculate that as a score. But the flaw with that is the pin may have fallen on the lane. So if you don't count that, then that's flawed, right? The only flaw with my system here is sometimes the collision box misses, and that'll happen if, you know, it bounces off and comes back in. So it will count as an additional overlap and then end overlap. So it's not foolproof. The only foolproof way is to make sure that it's calculating the rotation of the pins. All right, so I think that's about it with the game system. You've understood how to create your own assets, how to bring stuff in, make stuff within the engine, bring stuff from outside, modify them, get a gameplay system working, possess a player, have physics working for you, reset the level, get a scoring system so it all makes sense. And before I leave you today, I want to show you one project where you can actually also extrapolate this into a full featured game. And that involves a lot of other things, which is to do with environment design, level design, and all of that stuff. So I've just gone ahead and put this exact system that you guys learned today into an environment, so you get like a fuller picture of what is something that you can expect if you put in more time, right? So I'll just open that and show it to you, and then we can take questions if you have any questions at all. So again, this is not a environment that I have created, obviously. This is an environment from the Epic Marketplace, right? This was available when it was free, so I'd acquired it, and now it's available for me. So that just goes to say that keep track of free assets in the marketplace. You never know when you get to use them. And it's a fully fleshed out, almost fully fleshed out bowling alley, right? And I get to implement the same gameplay here as well. And it just works. And it just looks that much more prettier, you know? There you go. Mini game within the time frame that we have. And if you have any questions, I can take them up. Anyone, any doubts, any questions?
No, I think everyone seems happy, and you guys tired? It was hard work. Thank you very much, Rajeep. Thank you, Shruti, for everything. Hopefully we can see you here next time. Is he still around?
I hope so too.
Okay, cool. All right, thanks everybody. Go grab some lunch.
Thank you, guys.
Some water. Cool.
Rex, can you help me with the head count? How many people had joined?
We ended up with 4. I think there's some people up in Joburg on computers as well, so apparently, so yeah, let's hope. Cool.
All right, bye everybody.
Thank you. Cheers.
Thank you, Rasteep. Thank you, everyone. Bye.
Yeah, it's just my laptop just has decided to.
Yeah, he's just sending a black screen. Yeah.
Okay, just hold on a second. Joining me at this workshop. So we're going to be talking about fidgets, which, if you haven't heard of them, they are basically little controllers for hardware, which you can plug into your computer and do some interesting things with them. And that's what we're going to be speaking about. So I'm going to spend a couple of minutes talking about what they are, how to set up your environment to use them, and how to integrate them into Unity. And the idea is, at the end of this workshop, you should understand like the ecosystem a bit, and how to actually use them. I do have a few kits that I'm going to hand out, so some of you will be able to use this at home. Okay, so what they are simple I/O devices that let you connect a sensor to your PC, and those come in 3 different flavors. You can either use a USB, or as an Ethernet, or a wireless link, which means that your sensor can be really, really far from your computer and everything will work. Or they also come as a system on a chip, where the fidget board is built into like a mini PC, and you can run everything as a single unit. For this workshop, we're going to be using the USB one, but they all like work in very much the same way. So the fidgets give you 3 different kinds of input or output. So the one is just like a button, so it can handle input and output as if you switch a physical switch or lever, you can represent that as input. It can also accept a voltage range. So the idea is that you have a sensor that can give you a range. Like as an example, you have a slider, and as you increase it, the voltage will go up, and if you increase it, it will go down, and that's really enables you to plug in any kind of sensor that outputs a voltage and read it into your application. The third thing it can do is it can also do I/O out, where you can toggle LEDs or switch on relays from this thing, which basically means that, as an example, you could turn on a kettle from your application, if that's a thing that you want to do. And these units are usually used for home automation or industrial automation, but we kind of use these for our applications, which are more interesting in nature. And so the things that you can plug into these are essentially any kind of sensor that outputs a voltage. The Fidgets API, or the Fidgets ecosystem, has a whole bunch that you can just buy off the shelf. Like they've got like ones that can read vibration and distance and input, like multi-touch, and like it makes it really easy. Alternatively, you can really wire up any sensor you like. This one, as you can see in the image, reads humidity in the room, and they have a whole bunch of APIs that are available. Fortunately, they've got a C# API that works in Unity, which is what I'm going to be showing later. But they also have other ones like JavaScript, if that's more your speed. The typical use cases for these things are either if you want to build a prototype for some kind of input where you don't want to, or you don't have the skills to use a soldering iron. And then they're also often used in the real world in like an arcade experience or in experiential media, where people will be coming to a specific spot to use the application. These aren't normally used in consumer games because they are quite expensive, and you also have to install a third-party library to use this, which I'm going to show you shortly. Okay, so that's kind of the presentation part. I'm going to hand out some kits, and then we're going to go through a live demo, and some of it you should be able to follow along. Okay, so everyone's got a kit. There should be a USB drive in that box that I've given you. And I'm going to start going through things, and you can follow along if you like. Otherwise, yeah, just watch the screen. So the first thing one has to do to actually make this work is you need to install the drivers. And what they will do is they will create a control panel on your PC that's going to show whatever fidgets you have plugged into your computer. So I've already installed it, and it is on the flash drive, so you can go ahead and install it. What it'll do is, at the moment, I've got a fidget that's plugged in, and it can show me the 6 ports that are on it, which means I can have up to 6 controllers at the same time. In this case, on port number 0, or port 1 rather, I've got a slider that is plugged in, or do I? So it's in port 0, it looks like. And as I move that slider, the voltage goes up and down. So would everyone like to install the drivers, or should I just go ahead? Okay, you don't have stuff installed, but that's okay. So I'm just going to go ahead. So you will notice in your pack there's a USB cable, and then there is a little box that looks like this with 6 numbers on it. That is the fidget hub. That's the thing that plugs into your computer, and each of those ports represents an input that you can use, and there are 6 of them. I've also given you a slider with a cable. Yes. I don't know if Unity is installed. If you want to, you can. I can see it on this other computer here. So, but the actual Unity part's going to be very brief. So it's probably not going to be, like, you're not going to have enough time to install it now, I don't think. Okay, so the idea is that these controllers plug in via the cable I've also included. So in terms of making this work with Unity, there's one other thing that we have to do, assuming your fidget shows up on your computer, and that is inside of Unity. We have to copy the fidget's DLL into Unity in the plugins folder. You will notice that the fidgets library comes with a whole lot of different versions of this DLL. We're going to be using the .NET standard 2.0 version of the file. And what we're going to be building, which I'll just kind of show you now, and hopefully this will work without freezing the scene, is we're going to be building a little script that moves, or should move, this little white box if this works, and just make sure that this actually does a thing. Okay, I'm actually plugged in. I should be. Oh, I know why it's not working, and that is because I need to address the right port. So just give me 1 second. Don't worry, we're going to rewrite all of that, and I'm going to explain it step by step. So this should just be to demo the. Okay. Why is it not playing ball with me today? Okay. Well, we're going to figure this out while we go. I just want to check something. This is always the nature of live demos. They work great until you have to actually do them, and then it decides that, oh, that might explain it. And you close that. Oh yeah, if you have the control panel open, it doesn't like it because only one application can consume a fidget at a time. So you can see now that as I move the slider in my hand, the box moves up and down, and we're going to just write this up from scratch. So we're going to just comment out all the code. We're going to do this. And you can see it's not a whole lot of code. So I just want to point out that there's the library that you use has a namespace fidgets 22, and the API is very, very simple. So if you are going to be using a pre-made sensor like a humidity sensor, then it will come with its own class. So if I look for, let's see if I can find temperature. So you can see there's a class for a temperature sensor. In this case, we are just going to use a slider that controls voltage, and you can either ask for the voltage as its actual raw value or as a normalized value between 0 and 1, which is what we're going to use here because that's a lot more useful for our purposes. So the first thing I'm going to do is I'm going to go voltage ratio input. Let's call that a VRI. So I'm going to make one of these guys, and I'm just going to make a start method just like any other application for Unity, and I'm just going to make a new instance of this thing. Then there's a few steps that I need to do to configure this so that it knows what hub to join. So the first thing I'm going to do is I'm going to say VRI.isLocal is equal to true, because this hub is in a USB, so it's running locally and not in networked mode. I also need to tell it what port it's going to use. So you will see on the hub there are 6 of them, and I'm using port 0, so that's what I'm going to use. And then I'm also going to have to indicate that this is a hub device, which basically, so fidgets come in different flavors. This is the easiest one, this is the hub, so I've got to indicate that it's looking for a hub and not some other kind of fidget. And then the final thing one has to do is you just basically got to say open, and you give it some timeout range. Now, when you call open, that is a blocking call, so Unity will freeze until it finds the hub. But there is a way which we can solve that, which I will show you in a minute. And so that's how you open up the link to the fidget. And when you are done, very, very important, you just need to make sure that you have a private void on application quit. You have a VRI.close. The reason why that's really important is if the application ends and you still have an open link, it's going to leave a thread running, and it's going to make it very, very hard to reconnect unless you actually exit the editor. So like that's always a good starting point. So the next thing that we need to do is we need to also now read the information off of the sensor, and these things work with call backs. So we'll just say VRI dot, and just check voltage ratio change, and then we kind of need a callback that we're going to fire. We're going to call it on change, and we're just going to like implement this guy. Let's see if it'll let me do it. Cool, that's nice, autocomplete. So that's the method, right? So we have this on change method that's going to run every single time the slider value changes. Now, there's a bit of a catch here which makes it a little more tricky than it looks, and that is the on change method actually runs in its own thread. So if you put any code in this block that calls a Unity object, it's not going to like it. So I'm going to show you that. I'm going to do an illustration of what happens if you give that a try. And then I'll show you how to actually make it work the right way. So we got like an image, and then I'm just going to say on change, I'm just going to say if the image does not equal null, what's it, image? Image dot vectrons dot local position equals new vector 3 0, and then I'm just going to take the voltage range ratio that's a value between 0 and 1, and return that. It has to be a float. And now what I expect is going to happen is that this is going to throw an error when it tries to read that value, and we'll just give that a try. Let's see what it does. Why it didn't. Let's give that another. Oh, it's okay, because it's not going to run that code because it's null. Okay, so we're just going to assign that there. Let's see now, does it throw an error? It should. Yeah, so you can see here I'm getting the Unity exception. This can only be called from the main thread. So obviously, like, we can't just interact with this value straight away. And so the solution that you would normally use is you have to move this value from this thread onto the main thread, and we can do that with using a queue in a thread safe way. And so I'm just going to make a queue of the type double, which is what this thing returns. Values equals new queue double, and then what we're going to do is, instead of doing any of this, is we're going to say, okay, in this method, I'm just going to go lock values. So that's going to lock the queue object, which basically means when it runs this code, no other thread is able to use the queue, and they will wait until this is finished. Values.enqueue, and then I'm just going to say e.voltage ratio. Then what I will probably do is I'm going to write update method where I do a similar thing where I just have a lock in this thread where I'm saying, okay, when we are like reading it, we're also going to lock it, and then we're going to say while values dot count greater than 0. I'm just going to say debug dot log values dot dequeue, and if I haven't made a mistake, hopefully this while loop is not going to freeze and crash Unity, which we'll find out in a second. So what's going to happen, just to recap, it's going to run the on change in its own thread. It's going to enqueue that value for us, and then we're going to dequeue it in our update loop and do something with it. So now, hopefully, if I do that, I should get some logs out. You can see now I'm getting the log values from the sensor, and I'm not getting any errors. And now I can take this line that I had here, and I can stick it in here, and I'll say, okay, because this is a normalized value, what I'll probably do is, and then, okay, so what I have to do here is I'm going to say float value equals values dot dequeue, and because it's of type double, I've got to cast it to float, and then I'll say, okay, we'll do float value times screen dot height. What was it I used? Minus screen dot height divided by 2. I think that should give the same location. And now I can drive this box with my slider, and it took me like not very many lines of code and 15 minutes of time to write this up. So it's definitely an extremely powerful way of iterating with sensors and things that otherwise you would have to use an Arduino for, and then you might end up writing hundreds of lines of code and soldering things that wouldn't really be that fun to do. Then in terms of this, I also want to just illustrate, we'll just give this a try. So I've got this other sensor that looks like this. So what this is an infrared sensor. It kind of works in the same way. So this will also measure hand movements or anything above it. It will say how far away it is. So I have no idea if this is going to work, but I'm just going to change the port to port number 4. And then I can do like a sort of, let's see if this works. Let's see. So now as I move my hand, that box moves. So one other piece of information, the sensor also has a poll time, which means that it reads at a certain rate. For games, we would most likely want to increase that. And that's very, very easy. You just go VRI dot, I think it is, in fact, let me just read the code that I wrote. That's why I didn't remove it. I commented it out. It's, oh yes, data interval. And you can basically say, okay, I want to read from the sensor every 30 milliseconds. And then you get that information out. It's hard to see on the screen because the frame rate of the projection is low, but it will now run a whole lot faster on my machine, but I can't illustrate that, unfortunately. So that's kind of like a very quick overview of how to use a fidget in Unity. There's also another sensor in the box I gave you, and that is a little white tab with a magnet. Like when that magnet is on it, it's like it gives you an on event. If you remove the magnet, it gives you the off event. And to use that piece of tech, it's very, very simple. I believe it is just digital input. And it works in the same way. And that's going to give you an on event and an off event. You can also make your own one very, very easily by using the magnets from an alarm system. You just wire up two cables onto it, and you just attach it onto your fidget, like I've done in the example box. So that's basically everything in terms of the showcase of how this works. I know it's very, very brief and small, but my time is almost up. And I was wondering if anyone has any questions about this. So, yeah, okay, question.
I know this is a stupid question since you're actually here, but does it actually ship to South Africa?
So I ordered this all. It shipped in 3 days.
Oh, wow.
So yes. So okay, it's actually an excellent question. So one of the nice things about fidgets is they have a lot of stock. So like with a lot of these things, the issue is it's really, really hard to actually buy them, and then you can buy one, but if you want to buy 5, like that's a problem. And if you go to their website, you will see they've got a live stock listing, and they generally have like hundreds at a time, so there's no issue importing. Obviously, when you do import, you got to factor in duties. So when it arrives in South Africa, there's going to be an extra fee to get it out of customs. There's no way around that, unfortunately. So, yeah. Any other questions? Okay, yeah. Oh yeah, so yes. Yeah, so but like the expensive piece is the hub, which you've now got. It's about, I think this is probably about 800 Rand. But from here, you can wire up any 5-volt sensor that you can buy from Mantech or one of those guys for like 5 Rand. So yeah, so you can really go wild. So, because I mean, if you look at this thing, right? So like this one in the box is, yeah, so like that one, yeah. Yeah, so the guy's indicating how that works. Yeah, basically just wire them up. Obviously, you've got to kind of know what you are doing if you are doing that, but it's not that complicated. Any other questions? Yeah, we have. So the last time we used this was at the Science Museum in Kuwait. That was in 2017, and it was for a Mars rover. So they built like a Mars rover, and that was a combination of an Arduino and this thing. And so we used the fidgets to capture inputs from their joystick and then output those back to the Arduino via our app, because our app had to kind of, and then yeah, so basically what happened there was when the rover would enter a certain area, our app would pick it up, and then our fidget would send a message to the Arduino board on the rover. So yes, and they work like a bomb. And so these are like really industrial grade. You know, they will like they'll always work. I mean, what bodes well is I ordered 10 and they all worked, which is usually not what you find when you order these kind of things. So yeah, cool. Anyone else? Yeah. Yeah, so on their website, they've got really good API docs. So if you select the sensor you want, they will give you, you can then choose the language that you are interested in, and then they will give you a whole bunch of examples. So yeah, so it's very it's very well documented, and the APIs are very good. So okay, all right. Anyone else? I think that's it. If anyone never got a sensor and they want one, please come and speak with me, and I will organize one. Question? Okay, cool. We can speak afterwards. Well, you can. It's just not going to do anything. I mean, yes. I mean, you can call it. It will most likely throw an exception. It will throw an exception. Yeah. So, oh, that actually just, yeah, I wonder if this is going to wake up in time. Our laptop's gone to sleep. Let me see if the screen comes back. Yeah. So, there's one last thing I just want to show you, and then we can wrap up, and that is, if you want to make the open call non-blocking, you would just do this. Task.run, and do that. And that's it. And then Unity won't freeze, and everything will work as normal. So yeah, so that's it. I hope you found this interesting. If you have any other questions and you would like to ask, please do get hold of me. My email address is shane@renderheads.com. Okay, yeah. It's a pleasure.